SQL is a powerful and dependable tool for extracting relevant and useful data from large datasets. While SQL has traditionally been the domain of highly trained data analysts and programmers, it is gaining a lot of popularity nowadays among non-technical professionals as well. Also, looking at the job opportunities, we can see an enormous demand for SQL developers across the globe. Companies are recruiting fresh candidates in a full-fledged manner. So, if you're a beginner who is on the pursuit of learning SQL language, this training series on SQL will help you learn all the important aspects about the language and its various concepts from the scratch with theoretical knowledge as well as practical examples. Hello everyone, welcome to SimpliCode's YouTube channel. I hope you're doing good and staying safe. In today's session, we'll be taking you through the part 3 of this SQL training series program. Now, in our previous sessions, we have covered the basics and fundamentals in our previous session in part 1 and part 2. So if you guys have missed it, I would highly recommend to check that out on our channel. In today's session, we'll be covering some more important and new topics wherein we'll be covering some important advanced SQL topics. I hope I've made myself clear with the agenda for today's session. So let us just get on with it. But before we begin, if you're new to the channel and love watching tech videos, consider getting subscribed to our channel SimpliCode to stay updated with all the latest technologies. And hit that bell icon to never miss an update from us. Alright, firstly, let us discuss the agenda for today's session. We'll start this session by understanding what are functions in SQL and why we use them. And then we'll be explaining about cast and convert function. And then we'll be discussing about commit and rollback. Once we are done with this, we'll be understanding what is SQL-like and wildcard characters. After that, we'll be covering views in SQL. Next, we'll be performing an exploratory analysis using a data set, and we'll see how to find nth highest salary from an employee table. And once we are done with that, we'll be understanding how to delete duplicate rows from a table. And then we'll be going through what is pattern matching in SQL. Up next, we'll cover what are SQL triggers. And then we'll be understanding what is auto increment and how to use auto increment in SQL. Up next, we'll be covering normalization in SQL. Once we are done with this, we'll be covering some advanced topics like SQL indexing and SQL regex or regular expressions. After that, we'll be solving some top 5 tricky SQL queries using certain examples in MySQL database. After that, we'll understand common table expressions or CTE in SQL. Once we're done with that, we'll be understanding what is PLSQL, and we'll have a comparatively analysis on how PLSQL is different from SQL. After that, we'll be covering what is NoSQL, and similarly, we'll understand how is NoSQL different from SQL. And finally, we'll end the session by going through some important SQL interview questions that are asked during your placements. Well, I hope I made myself clear with the agenda for today's session. So without any further ado, let's get started with today's session. Over to our training expert. How to create a function in SQL. Now to create and for the execution part of the functions, let us jump into MySQL Workbench. So as you can see, MySQL Workbench has started, and before understanding the syntax of how to create a function, let us just understand what a function actually is. Now a function in SQL is basically a set of SQL statements that performs a specific task. Now if you have to repeatedly write larger SQL queries to perform a task, you can simply create a function for that. Now next time, instead of rewriting the whole SQL query, you can just simply call that function to get the desired result. Now these SQL functions are basically programs either developed by the user or already provided by the SQL system. Now we have several inbuilt functions or the system defined functions like aggregate functions, string functions, date functions, etc. Now other than that, we can create a user defined function as well. So firstly, let us go through the syntax on how to create a function. So the syntax is followed as delimiter, which I will explain in a while when we are creating the actual functions. So let us keep it aside for a while. Create function, function name, and inside the parenthesis mention the parameters. Now you can create a number of parameters as per your choice. The thing is, you have to mention the parameter name as well as its data type. Returns data type, deterministic, begin, and inside that we have to write the code, that is the actual code for the function. and use the end. So let me just explain how this syntax works. Firstly, we are specifying the name of the stored function that we want to create after the create function keyword. Next, we have to list all the parameters of the stored function inside the parenthesis followed by the function name. And then we are specifying the data type of the return value in the return statement, which can be valid using any data type here as well, like int, char, varchar, etc. And then we are specifying if a function is deterministic or not. Now, a deterministic function always returns the same value for the same input parameters, whereas a non-deterministic function returns different results for the same input parameters. So let me just explain this with an example. Now, if I take a function xyz and I am specifying a parameter, let's say p function, so it will always result the same answer as long as its input, that is p, is the same. And finally, we'll write the code in the body section after the begin keyword. So this code will be written in the body of the stored function in the begin end block. Now inside the body section, you need to specify at least one return statement. This return statement basically returns a value to the calling program. Now whenever the return statement is reached, this execution of this function is terminated automatically. So let us now understand this with an example. We have a query here which says like create a function bonus status which has one parameter salary of type char and returns varchar of size 20. Now we have to use the following operations in the statement to create this function. The first one is return eligible for bonus as the statement if salary is greater than 35,000, else return not eligible. So let us now write the syntax for this. So let me just switch to another tab and we'll write the query here. First, write the keyword, that is create function. Now the function is bonus status. Inside the parenthesis, mention the parameter. Now I'm taking parameter as salary here, which is of character. I am giving size as 20. Close the parenthesis. Now mention the return statement, that is it returns varchar of size 20. Deterministic is the keyword that we are using here. Begin, and inside this we have to write our main query. Now the query that we have earlier discussed is that if salary is greater than 35,000, then return eligible for bonus. Eligible for bonus, and close the parenthesis. Else return return inside the parenthesis not eligible. Mention the double quotes and close the parenthesis and put a semicolon. Now that's it. That is the end of our body. So now I'll use the end if statement, which will basically close the body of our function, and then I'll use the end operator here with the $sign, and that is it. This is basically our code to create a function. So let us now execute this statement and see the output. Now while I execute the statement, it will throw an error, and this is where we'll use the SQL delimiter. Now, as you know, when we write an SQL statement, you use the semicolon after the SQL statement. Like if you write a two separate statement, for example, if I say select star from, I'm taking an example as employee, and I'm taking another example as select star from orders. Now when I execute this query, it will throw an output because I haven't selected which query I want to execute. Now for that, we'll place an individual semicolon at the end of our statement, right? So in a similar way, MySQL uses the delimiter function to separate statement and executes each statement separately. Now, however, a function consists of a multiple statements separated by a semicolon. So if you used to define a function that contains semicolon characters, then it will not treat the whole function as a single statement but many statements. Therefore, you must redefine the delimiter temporarily so that you can pass the whole function as a single statement. So for that, we'll use the delimiter here. So let me just incorporate the delimiter here. You have to use delimiter with the help of double slash or double dollar sign here. You have to specify at the beginning as well as the end. Delimiter, and I'll mention 2 double. So that's it. Now our code is complete, and let us execute the statement now. So our query has been successfully executed. Now to see whether our function is created or not, let us just refresh the schema here. And as you can see in function section, you can see bonus status, which is the function we have created earlier, has been created successfully. So let us now just verify whether our function is working or not. So I'll just write a simple query as select bonus status. Let us take 40,000 as our example. So let me just execute this statement and we'll see the output. So as you can see, the condition which I've specified is if the salary is greater than 35,000, then the employee is eligible for bonus. Now since we have taken the salary as 40,000, it is showing as eligible for bonus. Now similarly, let's say if I take 20,000. And if I execute this statement, it will definitely show me not eligible. So as you can see, it will show not eligible for bonus. So in this way, you can create an user-defined function by passing certain parameters to get the desired result of your choice. So now that you've created a function, you can query an already existing table by calling that function in an SQL statement by passing certain parameters into that function. Let us understand this with an example. Consider the employee table here. So let me just display the records in that employee table. So as you can see, the employee table has various columns such as employee ID, employee name, age, designation, city, total salary, date of joining, and department ID. Now using these already created functions, let's say if I want to know whether the employee is eligible for the bonus or not using their total salary, I'll use the function. And to achieve that, I'll simply use the select statement to display the records. So let me just write the query here. Select. I want to fetch the employee ID, employee name, their total salary. So I'm mentioning the columns employee ID, employee name, their total salary, now I'll call the function here, that is our bonus status, and inside the function I'm going to pass the parameter which is the total salary, on which we'll know whether the employee is eligible for bonus or not. So I'm taking as total salary from the table that is employee. So let us execute this statement and see the output. So there was a mistake in the function name. So let us execute the statement now and we'll see the output. So as you can see, based on the total salary and the function that we have created earlier, it will result whether or not the employee is eligible for bonus or not. Now you can see the employee Rahul, who's having salary 40,000, which is above 35,000. So in this case, it is showing as eligible for bonus. Now if you consider another employee Varun, whose salary is 30,000, which is less than 35,000, so that is why it is showing as not eligible. In this way, and for the rest of the employees also, it will show the same as per the condition that we have specified in our function, that is the salary should be greater than 35,000. So in this way, you can simply call a function using its name and provide the parameter and get the required output. Now the other important thing to notice here is that we have used the function as a column as a parameter in our select query. Now we have passed the parameter that is total salary into our function, that is bonus status, and the function returned a result of this calculation. Now in this way, SQL function can be very useful as we have avoided writing complex calculations in a select query, and also we can reuse this function later in any other queries as well. conversion functions in SQL. We are going to cover about the cast and conversion, which are most commonly used conversion functions in SQL. More on that soon. But before we get started, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content, and hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Firstly, let us discuss the agenda for today's session. We'll start the tutorial by understanding what is cast function, and then we'll discuss what is convert function, and next we'll have a detailed comparison between the cast and convert function and see how they are different from each other. And finally, we'll execute these two functions in MySQL Workbench using various examples. So let us get started with today's topic. So firstly, what is cast function? The cast function in SQL is one of the most commonly used conversion function which allows the user to convert from one data type to another. It is very useful for concatenating results from various data types. Now this conversion can be either a single expression or the values from the columns in the SQL tables. It also allows the user to perform calculations on two different data types as well. Now using cast, it does not change the data completely in the database. This conversion of data from one data type to another is only valid while the query is running and is not permanent. That is, the changes to the query is only done on a temporary basis. However, it is possible to convert and insert into a new column or table as well. Let us now understand the syntax of cast function. The syntax is followed as cast expression as data type length. Expression here represents the data which we want to convert, and the data type specifies the data type which we want to convert the value, and finally the length of the data, which is optional. You can give it as per your requirement for only certain data types such as nchar or varchar. Now let us consider an example here which says select cast 76.87 as int. Here I am taking a string value which is 76.87 and I am converting this data type into the int value. Now the output is as expected, that is 76, which is an integer value. In this way you can use the cast function to change one data type to another data type in real time. Next, let us discuss about what is convert function. The convert function converts an expression in one data type to corresponding value in other data type. Now you might be confused that the convert is different from the cast function. Convert is similar to that of cast function as well, while the functionality of both these conversion functions is same. The only main difference is the syntax and the usage. So you can specify the format to convert as well as the data type in the convert function, and it is a very useful function especially for converting the strings to date formats. And the syntax is followed as convert expression comma data type. Now again, the data type parameter defines the target data which is to be converted. Now, and the data type parameter can take data types as an input such as big int, small int, decimal, numeric values, float values, character values, variable characters, nchar, etc. And the length is optional parameter which specifies the target data type length, and the default of this parameter is around 10 or 20. Now we also have the expression. This parameter specifies the value in which we want to convert to another data type. So let us consider an example here which is select convert 2022.06.07 as date. Now this is basically a string value, or you can say a part of a decimal value, and I'm changing this string or character into date format, which is 2022-06-07, which is converted into date format. So in this way you can use the convert function as well. Let us now understand the difference between the cast and convert function in SQL. Now both these SQL conversion functions are row functions which are capable of typecasting column values or an expression from one data type to another, and the functionality of both of the functions are almost similar, but there are some major differences in them as well. Now both the cast and convert function are used to convert one data type to another data type,
And one of the main differences is the syntax. Now the syntax of cast is very simple. It includes the value to convert and the type of resulting data type. It has as a keyword to separate the data type from the value, and there is an option to express the length, which is the integer that specifies the length of the target data type. And on the other hand, the convert syntax mentions the resulting data type first along with the optional length. There is another expression and another optional parameter called style in the convert function, which is only specific to the SQL Server database. Now this style allows formatting the data type and specifies how the convert function should translate or format the data type. Now apart from these, there are some certain differences as well. The cast is an ANSI standard function. That is, cast is considered as the American National Standard Institute's standard function. That means it is applicable to most of the SQL databases out there like PostgreSQL, MySQL, MariaDB, MongoDB, etc. On the other hand, conversion function is a specific function that is only restricted to mainly Microsoft SQL Server. Cast function is also more portable function of these two. It means that the cast function can be used by many databases out there. And also cast is considered less powerful and less flexible than the convert function. And on the other hand, the convert function is generally considered as a flexible function which allows more flexibility and is mostly preferred to use for date time values, etc. Convert is also useful in formatting the data's format as well. And finally, cast function is used to convert a data type without a specific format, whereas the convert function does converting and formatting data types simultaneously. Now, for example, cast cannot convert a date time to specific format, whereas the convert function can do that. So these were some major differences between the cast and convert function. I know you might be confusing at first because there isn't much difference between these two functions, and also there is no difference in the performance of these two functions as well. So it's just a matter of preference to choose which function to use. You can choose to use cast when you work with multiple relational databases and the syntaxes are pretty standardized, easy to remember, and since it is an ANSI standard function, you can use it in any database as well. On the other hand, if you need to specify the output styling, we can use the convert function for that. And even though the style is optional and is limited to certain databases like SQL Server, the cast function is often used to preserve decimal values and places while converting between decimal numeric values, whereas the convert function cannot do this. So it is a matter of requirement when to use both these functions, and it is up to the user to choose between these both conversion functions. So now that we've understood about these two functions, let us jump into MySQL Workbench for execution part.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
As you can see, MySQL Workbench has started and we can now work on our conversion functions. Firstly, let us discuss about the cast function in SQL. So let us take an example for this. Let's say if I want to convert a string value into an integer data type, then the following query would be select cast, and within the parenthesis, let's say I have a string value which is 45.68 and I want to change this into int data type. So I'll mention int as int, which is the keyword we use in the cast function. So let us now execute this statement and see the output. Now it will show me an error. That's because the int data type is not supported in MySQL Workbench if you're working on cast function. So instead of int, you can take the signed function, which is basically a sister group of the int data type. So you can take the signed integer as well. So let us now display this value. So as you can see, it will return me the 46, which will round off the decimal value, which is 45.68 to 46. Now let us take another example. Let's say I have a string value, I want to change it into date format. So then the following query would be select cast. So let me just take some string values like 22, 9, 24 as date. So let us execute this statement and we'll see the output. So as you can see, the string value that we have taken here, that such as 22/9/24, has been changed into date format, which is 2022, which is the year, 9 is the month, and 24 is the date, which is in the format of year, month, and date. Now, if you pass the values here, which is not in the range of the function that of the data type that you have specified in this function. For example, instead of 9, if I take 14, and let's say if I want to pass this function, then it will show me a null value. That's because the value 14 is not in the range of the date value. That is 14, there are only like 12 months, right? So the values it can take is only from 1 to 12. Now if you pass other than this range, then it will show an error. Now similarly, if I want to specify this value into datetime function, then I can simply mention the datetime function data type as well. So let us see the output. So it will show me the output in the form of date as well as the time format here. So let us now understand another example. Now, as discussed earlier, a cast function not only changes the data type of an expression, it can also change the data type of the column values in the table as well. So for that, let us take an example for this. Let me consider the restaurant orders table here. Now I have this price column which is in decimal values. Now let's say if I want to round off these values into integer values, then the following query would be select cast, mention the parameter which is price as signed from the table name, that is restaurant orders. So let us execute and see the output. So as you can see, the prices are being changed into the integer values now, and the decimal values have been rounded off. So similarly, if I want to mention the columns, I can mention them as well. So I'll take the item name, the previous price, and the change price. So I'm giving this change price as the new price as a new column. So let us now execute this statement and see the output. So as you can see, it will display the item name, the price, and the new price of these items. Now as you can see, the price of the tandoori mixed grill, which is 11.95, has been rounded off to an integer value, that is 12. And similarly all the other values as well. Now if you scroll down a bit, as you can see, we have a price which is 0.5 and the new price is changed into 0, which is not acceptable, right? Now the price hash should be of a value. Now instead of signed, if you can take the decimal data type wherein you can mention this, and it will change the value into the nearest value of the decimal value. Now as you can see here, the 0.5 has been rounded off to 1 here, and similarly 0.8, which is more than 0.5, is also rounded to 1. So in this way you can use the cast function to change the data type accordingly. So now that we have covered the cast functions, let us now see a few data type conversions here, which will help you understand the usage of the convert function as well. Now firstly, let us start with the decimal data type. Now as the name suggests, decimal produces a decimal value and has two optional parameters, which is basically m and d, where m is the maximum number of digits that you want to show in the resultant table, or which is also known as precision, and d is the number of digits after the decimal points from the scale. You understand with an example here. So the following query would be select convert, and inside the convert, mention the expression. So I'm taking the value as, let's say, 21.345, and I want to change this value into decimal data type. And inside the decimal, I'm mentioning the parameters. So I'm taking as, let's say, 7 as the total number of digits that I will display, and I'm taking only 2 decimal values that I want to display after the decimal point. Right, so let us just execute this statement and we'll see the output. So as you can see, it will show me only the 2 values, that is 35 after the decimal point. So the output is 21.35. Now the value that we have taken is 21.345, which is converted into decimal data type format, which is 21.35. Basically, it will round off the value of 345 into 35. Now similarly, you can convert the values into date and time data types as well in using the convert function. So let us consider the example for that as well. So select convert. Let's say now I have a value 10 comma 25 as date time data type. So we'll convert this into date time data type. So let us see the output. So as you can see, the string value which we have specified here as 11, 10, 25, it will be changed into the date time data type, that is 2011, 10, 25, and the time as well. And similarly, you can use the convert function to change a number or a string value into year type as well. So let's say I'm taking a value 22 and I want to change this string value into year data type. So the following query would be select convert 22 as year. So as you can see, the output, the string value that we have taken as 22 has been now converted into 2022, which is in the format of year data type. Now similarly, you can convert a string value into the time as well. So let's say I'm taking a value like, let's say 09, 17, 26, and I'm specifying the data type as time. So let us see the output for this as well. So as you can see, the string value that we have taken as 091726, which is basically a number, and we want to convert that number into time data type. So it will display the value as 91726, which is in the format of hours, minutes, and seconds. And that brings us to the end of today's session, guys. That was all about the MySQL conversion functions. We have studied and understood what convert and cast function does, how exactly it works, its parameters with some examples. Now you can try converting the value in every valid data type using these two functions, that is convert and cast.
We are going to learn about commit and rollback in SQL. Firstly, let us understand the agenda for today's session. We'll start the tutorial by understanding what is commit in SQL and discuss why we use commit. And then we'll understand what is rollback in SQL and discuss why we use the rollback command in SQL. And then we'll have a detailed comparison between commit and rollback and see how they are different from each other. And finally, we'll execute both these commands in MySQL Workbench. So what is commit and rollback in SQL? Commit and rollback are the commonly used transaction control language commands or TCL commands used in SQL. These TCL commands or transaction control language commands are basically used for managing and controlling the transactions in a database to maintain consistency. And it also helps a user manage all the changes made by the DML commands for maintaining its transactions. TCL lets the statements get grouped into a logical transactions. Now to understand more about commit and rollback, it is important to understand what exactly are transactions. Now a transaction is basically a block of SQL query or set of SQL statements executed on the information and data stored in the database management system. So any transaction when made happens temporarily or permanently in database. Now a user needs TCL commands to make these changes permanent or temporary. For example, if you're creating a record or updating a record or even deleting a record from the table, then you're performing a transaction on that table. So it is important to control these transactions to ensure that the data integrity is maintained and it also handles the database errors effectively. So generally you will incorporate many SQL queries into a group and you will execute all of them together as a part of a transaction. Next, let us discuss about the commit command in SQL. The commit command in SQL is a transaction command that is used to save all the changes made by a particular transaction in RDBMS since the last commit or rollback command is used. It signifies the end of a successful transaction in an SQL database. Now, generally the commit command is used after a data manipulation language or DML operations like insert, delete and update transactions. Now, when you perform a DML operation without a commit statement, the changes are only visible to you. Now, you can use a select statement and check the updated records from this modified data. But once you use a commit command after a transaction, the changes in the table or database are visible to other database users as well. Now, another thing to keep in mind is that the database cannot be restored to its previous state once the commit command is executed. All the transaction commands obeys the basic principles of asset properties in SQL, and the syntax for commit in SQL is followed as the syntax is basically uses just one keyword, that is commit, and you can use this commit using various YAML operators like insert, update, delete statements as well. Now let us say, for example, I have an employee table, and from that I want to delete an employee record whose ID is 110. Now when I perform this query, it will delete the employee ID 110, and then if I perform a commit operation, then it will permanently save that transaction. That is, it will completely delete the record from the table. Next, let us discuss about the rollback in SQL. The rollback in SQL is a command that is used to revert changes performed by a transaction. Now, whenever a rollback command is used, it reverts all the changes since the last commit or rollback that we have made in our SQL table. The syntax is similar to that. It includes just one keyword, that is rollback, and it is similarly used with the insert, update, delete statement. And let's say, for example, I am deleting a record whose ID is 105, and for some reasons, if I want that record back in my table, then I'll use the rollback command here, which will restore the deleted record, that is the ID of the employee who's having as 105. So it will revert back the changes that were made in the database by bringing back the original state. Let us now understand some differences between commit and rollback. The commit is used to save the changes permanently in the database, whereas the rollback is used to undo the changes and restore its previous states. The commit statement is basically used after an intended transaction which has been successfully completed. That is, if you're performing any SQL operations or transaction in SQL, and if you're sure that if there is no changes to be made for that transaction, only then you have to use the commit statement. Whereas a rollback statement is used after a transaction is unsuccessful due to any circumstances like system failure, etc. After executing commit command, any transaction can't be used for rollback, which we've discussed earlier. And on the other hand, after executing the rollback command, a transaction can be still modified and sent for commit again. So now that we've understood what commit and rollback are, let us jump into MySQL Workbench for execution part. As you can see, MySQL Workbench has started, and now by default, MySQL automatically commits the changes permanently to the database. So in order to force MySQL not to commit changes automatically, we use a following statement here, which is followed as set auto commit to 0. So let me just display this. Okay. It is successfully executed. Now, what this basically does is it will not commit any changes permanently that were done prior to the database earlier. Or else you can click on edit option here and choose preferences. And in preferences, you'll find SQL execution under the SQL editor section. So you'll find an option which says new connections use auto commit mode. So if you find a tick here in this checkbox, make sure you untick before you proceed to commit and rollback commands. So click on OK so that you are good to go now. So let me just consider a table here to perform the commit and rollback commands here. So for that, I'm taking the employee1 table as a reference. So let me just display the records from that table, and I'll use the select statement for that. Select star from employee1. So let me execute this statement. So in our employee1, we have various columns such as employee ID, employee name, age, designation, city, total salary, date of joining, and department ID. Now to commit the current transaction and make its changes permanent, we use the commit statement, right? So I'll use the commit command here and I'll execute this. So now basically what this does is it will permanently or save the changes that were done prior to this database, that is database table, that is the employee1 table. So let me just display the values now. So now let us perform some transactions on this table. So as we discussed earlier, we can use any DML operators like insert, update, or delete to perform operations using the commit and rollback command. So I'm going to use the update command here. So I'm basically updating the salary of an employee. Let's say Sanjana, whose employee ID is 1013, whose total salary is 30,000. Now I want to update that salary as 35,000. So for that I'm using the update statement. Update the table name, that is employee 1. Set total salary as 35,000, where employee ID equals to 1030. Right? So let us execute this statement. So as you can see, one row has been affected and our query has been executed successfully. Let me just display the records again. So as you can see, employee Sanjana, whose employee ID is 1013, her total salary has been changed to 35,000, which was earlier 30,000. Now, let's say in future I have this requirement where I want to have the original salary or the previous salary. Now for that I can use the rollback here. So when I execute the rollback statement here and select this table again, the total salary has been changed to 30,000 again. So basically we have done a transaction where we have updated the total salary of the employee Sanjana to 35,000, and after that we are again rolling back to its previous state, that is again to 30,000. Now similarly you can perform another transaction, let's say using the delete operation. Now I want to delete all the records from this employee 1 table whose designation is, let's say, business analyst. Now we have a total of business analyst 1, 2, 3, right? We have total 3 records. So we'll be deleting all these records from the table. So delete from employee 1, where designation equals to business analyst, right? So let me just execute this statement. Okay. Sorry, the column name has been written wrong, so that is why it is showing me as error. So as you can see, our query has been successfully executed and it shows 3 rows are affected. That means all the records of the employees whose designation is business analyst have been deleted. See, as you can clearly see, there are no records of business analyst records, right? So again, I have this requirement where I want to get back the results or the records of the employees who are working as business analyst from this employee 1 table. So for that I can simply use the rollback here. So we'll simultaneously perform 2 transactions here. Firstly, we'll update this table again, and then we'll delete, which was already done. So now let me just roll back this statement again. So when I roll back this statement and display the records from the table, as you can clearly see, the employee Sanjana, whose employee ID is 1013, her salary, which we have set as 35,000, has been reverted back to 30,000 to its previous or original state. And similarly, we have deleted the records of employees whose designation is business analyst, and similarly their records also have been reverted back. So in this way you can use the rollback command to get back to the current transaction and cancel its changes. Now let us take another scenario here. Now what if I perform a transaction before the commit command? So for that I'll take another example where I'll update the age of an employee. Let's say Rahul, whose employee is 1013 and his age is 26. I want to change it to 27. So I'll use another update statement here. Update employee 1 table, set age equals to 27. So his previous age was 26. Now I'm changing it to 27, where employee ID is 1011. Right. So let me just execute the statement. So it is successfully executed and we'll select the records. So as you can see, Rahul's age has been changed to 27 from 26. Now let's say if I commit this transaction, all right? So I'll just commit this transaction. So basically you cannot make any further changes to this record since we have committed the transaction already. So I'll perform the two transactions again here, which is basically updating the employee's total salary to 35,000 and deleting all the records of employees whose designation is business analyst. So let me just execute this. So as you can clearly see, all our SQL queries has been successfully executed. So let me just display the table here now. So as you can clearly see that the employee Sanjana, who's having one employee ID as 1013, her salary has been changed to 35,000, and we also have no records of those employees whose designation is business analyst. And similarly, the first transaction which we have done, which is updating the salary of employee Rahul, whose ID is 1011 to 27. Now let's say if I want to roll back all these transactions. So let me just roll back here and we'll see what happens. So our rollback has been successfully executed, and let me just display the records again. Now all the changes done past the last commit will be reverted if we roll back a transaction, since we have performed two operations or transactions after commit statement, which is basically updating the employee salary to 35,000 and delete the records of employees whose designation is business analyst. Now clearly we can see that their records have been reverted back to their original state. So like we have this employee named Sanjana, whose salary was 30,000, which is we have changed to 35,000, and since we have rolled back again to its previous state, it is 30,000. And similarly, we have all the records of the business analyst as well. But if you look at here, we have changed employee's age here. Like we have taken Rahul's age as 27, which was earlier 26, and we have changed that to 27. But even after rolling back this, we haven't got the original record, that is his age as 26. That's because we have already committed this transaction. So it will basically not revert back to its previous state. So once the commit statement has executed the modification made by the transaction, it cannot be rolled back again. However, once the rollback statement is executed, the database reaches its previous state. So that brings us to the end of today's session, guys. Now that was all about the commit and rollback commands in SQL. So basically, to ensure that the changes made by the transactions are permanently saved in the database, we use the commit after the transaction's successful completion. In case the transaction faces any error while execution, then to undo or revert the changes done by the transaction, a rollback command is used. Now you might get a doubt that where we have to use this and where this is applicable. Now if you are an SQL developer or even a beginner who's working on a database, let's say you're working on a database which has thousands of records and you're modifying, let's say 100 records in that. Now due to some errors, you want to revert back all the changes that you have made, right? So for that, you'll basically use the rollback function for that. So in this way, it will be helpful for getting the records again back to its original state. We are going to learn about SQL-like operator and wildcard characters used in SQL. Firstly, let us understand what is SQL-like clause. The like operator is used to find specific characters in a table's column. It is also used to compare columns with the specified values. Together with the where clause, it determines if a pattern matches specific values in a table. It uses wildcard characters, which are characters used to replace one or more characters in a string. To fulfill this purpose, you can also use like when only a portion of the value in that table is known. Let us now understand the syntax. The syntax is simple. It is usually used with the select command, and the syntax of this is followed as select column 1, column 2, so on up to column n from table name, where column name, like, and pattern. Now basically the columns to be shown in the result table are specified after the select statement. The column that is designed for pattern matching is specified in the where clause, and the pattern forms from the specific row selection, which is defined in the pattern parameter of the like operator. Now the like operator is case insensitive. That means you can either give capital or small letters as well. Now multiple patterns can be specified with this operator using the and or keywords as well. And wildcard characters are the most vital tools of this operator. So let's go over what these are and how they're used with the like operator. So what is wildcard character? Now wildcard characters are special symbols and characters used to represent one or more than one character in a string. These are imperative to the like operator as these enable patterns to be specified. That is, it filters the data using certain patterns to identify a value of a string in the database. Now, the two wildcards used with the like operator are generally percent and the underscore. Now, the percent sign is used to represent 0 or one or more characters, whereas the underscore is used to represent exactly one character. Now, to get a clear picture of both these characters, let us look at an example in a SQL statement and see how they are used. Now, consider this following example, which is select employee ID, employee name from employees, where name like a%. Now, from this table employee, if you want to know the employee ID of all the employees whose names start with a letter or character A, you should use this following query, which is the character or the pattern we are using here is a%. Now, as we discussed earlier, you can also use a small letter a instead of capital letter A because the like operator is not case sensitive. Now, there are many operations that you can perform using by specifying different patterns using the like operators. Now, for example, if you have to find a value that starts with A, then the following query would be where column name like a pattern. So basically, we are mentioning the pattern here as a%, which will retrieve all those string values which starts with the character A. Now, similarly, if you want to find values that end with, let's say, sh, then you have to use %sh. Now, similarly, if you want to find values that can have a character A in any position, then you have to mention the pattern as where column name like %a%, which basically returns any values that contain the letter A in any position. And similarly, you can use the underscore operator as well. Let's say if you want to return only return exactly one character, then you have to mention a single underscore sign. Now, let's say if you want to find values that have a character A in third position, then the following query would be where column name like, and within the single quotes, you have to mention 3 underscores. That is 3 times you have to specify the underscore that would be present before the character A, and then you have to mention the %. And similarly, you have these different types of operations, which you can take a screenshot of this by pausing this video now. So now that we've understood how exactly SQL like works, let us jump into MySQL Workbench to understand in depth on how these exactly work by using their different examples.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
As you can see, MySQL Workbench has started, and in order to execute the SQL-like operator, let us consider a following table in our database, let's say new employees, on which we'll apply various operations using the like operator. So let me first display the records that are present in the new employees table, and for that, I'm using the select operator. And the query is select star from new employees. So let me just execute this. And the new employees table has various columns such as employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and department. So firstly, let us discuss some examples using the %wildcard, which basically uses the percentage sign, right? So let's say if I want to fetch the details of all those employees whose first name starts with A, or let's say S, then the following query would be select star from the table name, that is new employees, where is the conditional clause, first name like is the keyword, and within the single quotes mention S%. Now it is important to enclose all the patterns that you have specified in a single inverted comma, otherwise the query will return a syntax error. So let me just display this and execute this. So when you execute this query, it has returned me 7 rows, as you can see in the output, which basically returns all those employees' name whose first name starts with the character that is S. So we have like different employees like Susan Mavris, Shelly Higgins, Shelly Bida, Sigal Tobias, and etc. Now, similarly, let's say if we want to fetch the details of all those employees whose last name or like first name ends with, let us take a character, let's say N. So let me just display and execute the query. So when you execute this query, it basically returns all those employees details whose first name ends with M. Like for example, if you consider here Susan Mavris, whose first name has N in the last position, and similarly we have Herman Bayer, John Chen, Den Raffley, and etc. Next, let us take another example. Let's say if I want to select all the employees whose first name starts with, let's say, S and ends with, let's say, N. So then the following query would be select star from new employee where first name like, now the first character would be S and you have to mention the percentage symbol, and the last character would be N. So let me just execute this statement. So as you can see, we have records of 3 employees whose first name have the letter or the character S in the first place and the character N in the last place. For example, Susan Mavris, in the first name we have S in the first place and N in the last place. Similarly, we have Stephen Markle and Stephen Stiles. Now let us take another example. Let's say I want to find the details of the particular employee. Now the thing is, I don't know the exact name of that employee, but I know that his salary is somewhere between 30,000 and 50,000. So for that I can use the AND or operator here. So the following query would be select star from new employee where first name like, let's say if I know the employee name starts with K, okay, then we'll mention the percentage symbol and we'll mention the AND operator here, and salary between 30,000 50,000. So let us execute this statement and we'll see the output. So when you execute this, we can see that there are no records in the table. That means there is no employee whose name starts with K and his salary is between 30,000 and 50,000. So let us take another example. Let's say the employee's name starts with J. So, and his salary is somewhere between 30,000 and 15,000. So let me just execute this statement. Now, as you can see in our result set, we have 3 different employees, Jennifer Valen, Julia Nair, and Jason Malin, whose salary is between 30,000 and 50,000 respectively. Like we have 44,000, 32,000, and 33,000. So in this way, you can find the details of employee even if you do not know the complete details, but just by specifying the pattern of their name or the character that we have in their name, you can fetch their details. Now, if you want to, if you further know their department ID, let's say Jennifer Valen department ID is 10 and she belongs to that department, and I want to get the details of that employee only, then I can retrieve their details in this way. So I hope you've understood how to use the percentage sign to find the different patterns in order to find the complete string value from the table. Let us now discuss some examples using the underscore while character using the underscore symbol. So let me take an example here. Let's say if we want to fetch the details of all those employees who have exactly 3 characters in their first name. So in that case, the following query would be select star from new employees where first name like, and within the quotes. Now we've discussed there should be only exactly three characters in their name, right? So we'll mention the underscore 3 times. 1, 2, 3. Close the single brackets and let us execute this statement. So as you can see, it has fetched a total of 4 records. For example, Pat Fay, we have only 3 characters, that is P-A-T in his first name, and similarly we have Lex, Dehan, Den, Rapidly, Guy, Himuro. All these employees have only exactly 3 characters in their first name. Let us now take another example. Let's say if we want to select all the employees with the first name that starts with S and are at least 5 characters in length, then in that case the following query would be select star from new employees where first name like single quotes. Now the first character would be S, so I'm mentioning S, and after S we have to mention the underscore 4 times. That basically means it will return an exactly at least 5 characters in our employees table who's having the first name having 5 characters. So let me just execute this statement and we'll see the output. So as you can see, we have 2 records of employees, Susan, Maurice, and Sigal Tobias. Now if you look carefully, Susan, whose first name has a total of 5 characters, that is S-U-S-A, and that is 5. And similarly, we have Sigal. Now, if you want at least, let's say 5 characters in length, then you have to mention the percentage sign. So it basically means the employee's name will start with S and it will have at least 5 characters in length. So let me just execute this statement. So it will display all those records whose first name starts with the character S and have at least 5 characters in their first name. So we have Susan Mavres, like we have also Shelly, who's having let's say 1, 2, 3, 4, 5, 6, 7 characters in total in her first name. So in this way, it'll retrieve all those values whose first name starts with S and basically have at least 5 characters in length. We are going to discuss one of the most commonly asked SQL query during job interviews as well as campus placements, that is how to find the nth highest salary in SQL. Now there are many ways to find the answer to this query, but in today's session we are going to discuss the easiest and the most simplest way to find the nth highest salary in SQL. Let us jump into MySQL Workbench for execution and understand how to find the nth highest salary in SQL. As you can see, MySQL Workbench has started. Now in order to find the nth highest salary, we need an employee table. And for that, I'm going to consider the new employees table here. So let me just display the records that are present in the table. And for that, I'll use the select statement and the query is followed as select star from new employees. So let me just display the results. So as you can see, the new employees table has various columns such as employee ID, first name, last name, email, phone number, hiring date, salary, manager ID, and department. So firstly, before discussing how to find the highest salary, let us see how to find the maximum salary. Now to find the maximum salary in SQL, you can simply use the aggregate function max to find the highest salary in SQL. So the following query would be select max salary from the table that is new employees. So let me just display the results. So as you can see, it is showing as 93,000, which is the highest salary in our table. Now, next, to find the second highest salary in the above table, we'll use the concept of subquery, which means that firstly, we'll find the highest salary in the table and then we'll nest that query to a subquery to find the second highest salary in SQL. So the query would basically be as, now I'll put this as a subquery here. And I'll write the outermost query now. That is select salary from the table that is new employees where salary is less than this inner query or the subquery. So let us just execute this query and see the output. Now it will display all the salaries that are greater, that is less than the subquery that we have written here, that is the maximum salary, which is 93,000. Now that is not the answer that we want or the results that we want. Now we want the maximum salary which is less than the 93,000. So I'm going to take the max function again here. So basically how this query works is, firstly the inner query gets executed, which is the maximum salary, that is 93,000. Next, the outer query executes, that is, it will select the maximum salary from the new employee table, which is less than the 93,000. So let me just display the results. So as you can see, it is showing as 90,000 as the second highest salary. So let us just verify whether it is correct or not. I'll use the select statement again. Select star from new employees. We'll use the order by function, order by salary, and I'll display the values in descending order. That means from highest to lowest. So in this way, we can find the highest salary and the corresponding salaries that are less than the highest salary. So as you can clearly see that we have 93,000 as our highest salary and the next salary as 90,000 as our next second highest salary. Now, till now it is fine. Now, let's say if you are asked to find the fifth highest salary, or let's say 20th highest salary, or basically nth highest salary from this table. Now, you can't keep on adding subqueries to this already written query, right? It will become time consuming and it becomes complex as well. Now, in general, there are two ways to find the nth highest salary. The first one is using the limit clause, and the second one is using the dense rank function, which is an inbuilt function provided by SQL, which we are going to discuss about in a while. So firstly, let us discuss about the limit clause and how we'll use the limit clause to find the nth highest salary here. So firstly, let us understand the syntax here. Now the syntax is followed as select column list from table name order by expression limit n-1 comma 1. So let me just explain the syntax here. Now after the select statement, you will have to mention all the columns that you want to fetch in your resultant table from the table name order by expression, which is this basically the column name you have to specify here, and you're using the limit keyword. And after that, we have two parameters here, that is n-1 comma 1. Now in the syntax, the limit n-1 comma 1 clause returns one row that starts after the row n. Now in other words, if I have to define this, the first parameter, that is n-1, defines after how many rows it will start fetching the records in our resultant set. And the second parameter will basically return the number of rows in that table. So let me just explain this with an example. So select. Now I'll use the distinct keyword here, which will basically remove all the anomalies or the repeated values in our table. So distinct salary from table name, that is new employees, order by salary, limit. Now let's say if I want to find the 10th highest salary in our table, so now our n becomes 10, so the value here, it will be n-1. So 10-1 is basically 9 comma 1. Now what this query basically does is it will return one record after the first 9 rows. That is basically the 10th row, which is the query that we want, that is to find the 10th highest salary. So let me just execute this statement. Okay, there is an error. So yes, the query is returning me as 24,000, which is the 10th highest salary here. Now similarly, if you want to find the, let's say, 24th highest salary, I'll just change the value into 24. So so basically if you want to find the 24th highest salary, you will have to mention 23 here, that is n-1, right? So let us find the output. So the next highest salary is 48,000. So I forgot to mention the descending keyword here. That is why it is showing me the highest value. So if I run this query again, so the 24th highest salary here is 29,900. So in this way, you can basically use the limit clause to find the nth highest salary. Now let's say if I want to fetch the complete details of that employee who is having the 24th highest salary, I'll simply use a subquery here. So I'll put this query as a subquery and I'll write another outer query using the select statement. Select star from new employees where salary is equals to the inner query. So let me just execute this query and we'll see the output. So now it will display the complete details of the employee, their employee ID, first name, last name, email, phone number, their salary, manager ID, department, and etc. So in this way, if you want to fetch the complete details as well, you can use this subquery here. Now let's say if you are asked to find the first 5 highest salaries in the table, then the parameter here will be changed. Now here our n value becomes 1, so the n minus 1 becomes 0. Now, and we want to fetch the first 5 records from the table, so we'll mention 5 as our second parameter, which will basically display the first 5 records. So let me just display and execute this statement. So as you can see, it will display the first 5 highest salaries starting from 93,000, 90,000, next 88,000, 83,000, and next 82,000. Now, if you observe this query carefully, it is somewhat similar to that of the top function we use. Now, since top function is not applicable in MySQL, we are using the limit clause here. Now, if you're working on different other databases like SQL Server or MongoDB or Oracle, you can use the top function. Now, the format will remain the same, only the syntax will change with the use of top keyword. So, in this way, you can use the limit clause to find the nth highest salary. Let us now discuss the second way, that is using the dense rank function. Now, MySQL dense rank function is an inbuilt function which is used to return sequential numbers starting from 1 based on the ordering of rows imposed by the order by clause. Now, when you have 2 records with the same data set, then it will give the same rank to the both rows. So, firstly, let us understand the syntax here. The syntax is followed as select column list. These are basically all the columns that you want to fetch in your resultant table. Comma dense rank is the keyword we use here, over, and inside the parenthesis we are writing the order by clause, and we'll mention the expression as, and we'll give a alias name to this dense rank function from the table name. So now basically the function is always used with over clause here, which will always assign rank on basis of the order by clause, and the rank is also assigned to the rows in a sequential manner. That is, the assignment of rank to these rows will always start from 1, and the next value will be 1 greater than the previous rank assigned. So let us understand this with an example. Now let's say I'll use the select clause here, and I want to display the employee ID, the first name of the employee, last name, comma salary, and next I'll mention the dense rank keyword, over, and inside the brackets use the order by clause and mention the expression. Now we want to specify the condition here, which is basically on the salary, right? We want to find the nth highest salary here. So we'll specify the salary here as let's give an alias name, let's say rank salary from the table, that is new employee. So let us execute this statement and we'll see the output. So as you can see, it will display the employee ID, the first name, last name, salary, and the rank of the salary. Now, since we haven't given any a keyword here for descending and ascending, it is showing in the ascending order by default. So let me just write the descending keyword by using the DESC. So let us now display this. As you can clearly see, it will display the records from highest to the lowest value, and the rank is assigned accordingly. Now for the salary 93,000, it is giving rank as 1, and for 90,000 2, for 88,000 3, and so on. Now if you look here, like the employee Adam Fripp, who's having 82,000 as salary, and similarly John Chen, who's also having 82,000 salary, and the rank is assigned as 5, which is same. Now if you carefully look here, it will assign rank based on the value and not on the number. So even if the values are repeated, it will assign the same rank to that value. So I hope you understood how to use the dense rank function here. Now let's say to find the nth highest salary, we'll have to use a subquery here. Now basically I'll keep this as a subquery here, and I'll use another select statement. So basically I want to again display the employee ID, first name, last name, and salary in a resultant table. So I'll just copy this and keep it as an outer query from this table, right? So, and I'll mention a where condition where rank salary is equals to, now you can mention the nth highest salary. Now whatever you want to display, you can mention this here. Now let's say if I want to find the 32nd highest salary, I'll just mention the rank salary equals to 32. So let us now execute this statement and we'll see the output. Now it will show me an error basically here which says every derived table must have its own alias name. So we have not given a specific alias name to our table here. So let us just give alias name, let's say as E, or you can take EMP or anything as per your choice, right? So let me just display this and we'll see the output. So as you can see, the 32nd highest salary has been assigned to the employee Hazel Phil Tanker, whose salary is 22,000. So let's just check whether it is correct or not. I'll just copy this dense rank select statement again. So let's just scroll down, and as you can see, 32, which is the rank here, has been assigned to the employee Hazel Phil Tanker, whose salary is 22,000. So which is correct, and you have successfully executed query in this case. Now similarly, if you want to find another employee salary, let's say if you want to find 16th highest salary, we'll take this and we'll execute the statement, and it is showing me as the 48,000, which is the 16th highest salary, and the employee ID is 105. The employee name is David Austin. Views in SQL. What is view in SQL? A database view in SQL is like having virtual tables containing a single query and its result. The result is usually a virtual table with rows and columns, just like the actual table in a database. We can either pass a query to store all the rows and columns of a table or only a part of it. Now, the most significant advantage of a view in SQL is that it stores the query, and hence we don't have to write it again and again from scratch. Now, but then a question arises, why not use the stored procedure instead? Even the stored procedure can hold a query and execute whenever called. However, the advantage with view is that they are easier and more straightforward compared to procedures. While procedures can have multiple statements with them, views can have only one. Also, views do not accept any parameters as in case with the stored procedure. Now, SQL views can be considered as one of the database objects which is created over an SQL query. It simply represents the data returned by an SQL query. So a view does not actually store the data in the tables, but every time we call a view in the database, it returns the result set of the query in which it is defined. So in a nutshell, we can say that a view is similar to that of a relational database table, which can be treated as a virtual table, and it is just a mere representative of an underlying SQL query. It always fetches the data from base table that are used to create the view using the view creation query. Let us now understand the syntax. The views in SQL are created with the create view syntax, and creating views in SQL is very simple. Following is the basic syntax to create a view in SQL, and it is followed as create view, view name as select column 1, column 2 up to so on column n from table 1, table 2, table n, where condition. Now to see the data in the view, we can query the view using the following select statement. Now create view is used at the start of the code to initiate the view, and then select is used to decide which columns to pick from the tables. Now table 1, table up to so on, table n denotes the names of the table. However, you can work on a single table as well. Now where is used to define the condition, which is used to select only a particular number of rows. Now another significant advantage of views is that it allows certain operations like insert, update, delete, just like you perform in a normal SQL table. Now other than this, we have other operations which can be performed using the view. Now view is used to filter records using where clause. Now we know that there is a lot of chunks of data in our database, and if we want only a part of it, we can filter the data using the where clause. Similarly, we can select columns from a single table as per our need. And in the same way, we can use the group by clause to select only a particular or a summarized result of a resultant set. And finally, we can also select columns from multiple tables using the join condition as well. So now that we've understood what exactly views are, let us jump into MySQL Workbench for execution part.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
So as you can see, MySQL Workbench has started, and before we proceed into the execution part and see how to create a view in SQL using various examples, let us first quickly understand why we use views in SQL so that we'll have a clear picture before we get into the execution part. Now, there are various reasons for using views in SQL. The first one is majorly because of security reasons, right? Now, views provide security to the data, acting as a security mechanism, and views can actually enhance security by restricting data access to users. For instance, we can limit a user from accessing the actual table that contains sensitive data, but provide access to the view that has only insensitive data. Let's take an example to understand this. Now, in a company, there is an employee, HR, and a manager who might be working on a same database table to fetch some information. Now, because they are from different departments, there must be some data that might be irrelevant to HR, but it might be relevant to the manager. And in other case, that data might be relevant to manager, but it might be irrelevant to the employee. So in that case, there should be a security mechanism that would hide irrelevant information of the table from certain usage. Now, views allows us to hide or show some data of table depending on the requirement and security. With the help of conditions, we can hide some data for a particular person. Now, the second reason is because of to reduce the complexity. Now, views are introduced, or they were actually introduced to reduce the complexity of the multiple tables and deliver data in a simple manner. Views hide the complexity of the data in the database as they join and simplify multiple tables into a single virtual table, which is easier for a user to understand. And finally, because of consistency reasons. Now, views also maintain the data integrity as it presents a consistent and accurate data from the database. You can easily make changes to the views according to the user requirement, and the effect of the same will be seen quickly in a quick manner. So now that we've understood why we use views in SQL, let us just quickly get into the execution part now. Now we can easily create a view in SQL from a single table or even multiple tables using the create view statement. Now, but before we create a view, we'll create a table named customers that we will use throughout this session now. So let us just create a table first, which is a customer table, and the syntax is create table customer. And in the customer table, I'm going to create various columns or fields such as customer ID, customer name, age, address, and I'm giving customer ID as a primary key because it uniquely identifies each and every record in the table. So let us just execute this statement and we'll see the output. So our query has been successfully executed. So let me just use the select statement to display the result. Select star from customer. Right, so our table has been created and the fields customer ID, customer name, age and address are being displayed. Now let us quickly insert some values in this table. Now I'll use the insert statement for that. Insert into table name, which is customer, values, and within the brackets, now customer ID let us take as 101, name let us take as Kiran, and age I'm taking as 25, and address I'm taking as Hyderabad. Right, so let us execute this statement and we'll see the output. So our query has been successfully executed and the information has been inserted into our table. So as you can see, the details of Kiran has been successfully executed and displayed in our table. Now similarly, I'll insert some more records into the table. So let me just copy this insert statement. So let us change the values here, 102, 103, 104 and 105. And name also let us change. I'm taking another customer name as Priya, Kushal, Vaibhav, and let's say Gayatri. And let us change their age as well. I'm taking as 26, 24, 28, and 23. Now you can change their address as well. So I'm taking the address for Priya as Bangalore. For Kushal, I'm taking as Mumbai. Let us just remain Hyderabad for Vaibhav itself, and let us take as Chennai for Gayatri. So let us just execute this statement and we'll see the output. So our query has been successfully executed. Let me just display the values now. So as you can see, a total of 5 records have been inserted into our table. Now we can proceed into creating a view for our table customer. Now to begin with, we'll create a simple view from our customer table, which is an existing table which we've created just now. So the following syntax would be create view, which is the keyword we use. You can give any name to your view. Let's say customer view, as select the columns that you want to display in your resultant view table, which is a virtual table, right? So I want to display all the fields in my resultant view table. So I'll use the select star operator, select star from customer. So let us execute this statement and we'll see the output. So our query has been successfully executed, and now when you refresh the schema section, you can see in views, you can find a new one which is created as a customer view. So let me just display the results in the view. For that, I'll use the select query again, select star from customer view. So as you can see, the exact details of the customers that we have already inserted in our previous table customers has been inserted in the customer view as well. So that means in this way, this view will store all the columns that were in the customer table, and it will simply copy paste all the records from customer table into the customer view, which we have created now. Now, similarly, you can also create a view from the existing table as well. So for that, let us take an example. Let's say if I want to create a view of projects table here. So let me just display the records from the projects table. And we'll see the output. So as you can see, the project table has various fields such as project ID, employee ID, project name, project manager. Now let's say I've had a new requirement wherein there is a new employee who's joining as a fresher into the company, and as a manager I want to show the details of all the project names that the company is currently working on. Now I want to hide the employee ID details because I don't want the fresher to have exact idea on which project the current employees are working. So for that, I'll create a view, a simple view here, which will basically give all access to the fresher or the employee who have recently joined. He can only view the project name and project manager's name. That's it. So let me just create a view here. Create view. Let us take the view name as project view again. As select the columns. Now I'll just select the project ID, the project name, and the project manager's name here. Project managers from the table, that is projects. So let us execute this statement and we'll see the output. So our query has been successfully executed. Now when you refresh this again, you can see another view is formed in the views section, which is the project view. So let me just display the records that are present in this view. I'll use the select statement again, select star from projects view. So as you can see now, only the project ID, the project name, and the name of the project manager are being displayed without displaying the employee IDs in this view table. So it will basically encapsulate or hide the unwanted details for the new employee so that he can only view the project name and the project manager's name itself. That's it. Right, so that brings us to the next segment wherein we'll understand how to perform various operations in a view in SQL, that is, how to insert, update and delete records in a view. Now, just like actual tables, we can easily insert, update and delete rows in a view that is not allowed in stored procedures. Now, firstly, let us discuss how to insert a row in a view. For inserting a row in a view, we'll use the project view as an example that we have created earlier. Now the view already had, let's say, I think 10 rows, and we'll insert another row using the insert into command. So the following syntax is insert into name of the view, that is project views, project view values, and inside that, let's say I'm taking project ID as 1120, comma, project name, let us say artificial neural network, comma, and let us say the project manager name is Akash. So let us execute this statement and we'll see the output. So our query has been successfully executed. So let me just use the select statement again to display the records. So as you can see, there's a new record with the project ID 1120 and the project name is artificial neural networks and the project manager name is Akash. So as we can see in the output, in this way we can create another row by inserting in the view, which confirms that the insert statement has been successfully executed. Right. So next, let us discuss how to update a record in a view. Now, just like inserting, we can also update a row in a view. If you notice the previous example, we have inserted a new row that is with the project ID as 1120. Let us update one of the record in this. Let's say if I want to update the project details of blockchain technology as something else, I'll use the update statement here. So the syntax for the update would be update, mention the view name, that is project view, set. Now since we are changing the project name, I'll mention the field project name, set project name equals to. Now let's say if I want to change the project ID 110 as, let's say, SEO optimization, or let's say SEO analytics, where project ID equals to 1110. Right, so let us execute this statement and we'll see the output. Our query has been successfully executed, so let me run the select statement again to display the records. So as you can clearly see that the project ID, which was 1110, which was earlier blockchain technology, has been changed into SEO analytics. So the updated the version of the column name, which was blockchain technology, has been changed into SEO analytics successfully. Thus, it is confirmed that the update statement has been executed successfully as well. Now, finally, let us see how to delete a record in a view. Now, just like how we inserted and updated a row, we can also delete a row using the delete statement. For example, we will delete the row which is having project ID, let's say 810. Which is project name as diabetic retinopathy and the project manager name is Harsh. So let me just delete this record. So I'll use the delete statement here. Delete from project view, where is the condition we use here, where project ID equals to 810. Right, so let me just execute this again. So our query has been executed successfully. Let me just display the records. So as you can see, the record, the project ID which is having 810, which is one of the record in this table, has been successfully deleted. So in this way, you can perform various such operations which we actually generally perform in the normal SQL tables, you can similarly perform them in SQL views as well. Now, for some reasons, if you want to delete the whole view, that is the view that we have already created. Now, for some reasons, if you want to delete it, you can simply use the drop command here, which will completely delete the view that you have created. So the query would be drop, mention the view name, which is project view, right? So let us just execute this. So our query has been successfully executed. So let me just use the select statement to display the records. Select star from which is project view. Right, so let us execute this. Now when you execute this, it will simply say that project view does not exist, which means that our view which we have created has been successfully deleted from the database and the schema as well. And that brings us to the end of today's session, guys. I hope you understood how to create a view in SQL. Now you might have a doubt that when to use views in SQL. Now since views have both advantages and disadvantages, the question arises when to use them, right? Now, for instance, if you remove an attribute or if you actually delete a table, it can impact the functionality of a view as well, just like in a related table. For instance, if a view is using the email column of a table and you drop that column or even a single data of it that is in use by the view, the output of the view will be impacted. Now, the short answer to when to use views in SQL is when you want to write complex select queries that require gathering data from multiple tables. In that case, you can use SQL views. Now, in order to understand how to delete these duplicate records in SQL, let us jump straight into MySQL Workbench for execution part. So I hope you are able to see the MySQL Workbench window. And as you can see, the MySQL Workbench has started. And on the left side, you can see the SimpliCode database where we have different tables such as Crypto 2022, Customer, Department, Employee 4, Employee 3, and so on. Right, now before we get into the execution part wherein we'll discuss how to delete the duplicates in SQL, let us understand why there are actually duplicate records in SQL. Now, as you know, sometimes you might see more than one copy of the same record appearing in your MySQL database table. Now, this usually happens after importing data from external sources such as spreadsheet applications like Excel or from external websites like Kaggle and etc., which do not have the features of relational databases, right? So having these identical copies of the same record may negatively affect your application and your business logic. So to overcome these challenges, you must need to delete the duplicate records from your table. Now, only rarely you will find to remove duplicate entries from a table, because the tables in these databases generally have this constraints such as primary key or unique constraints to prevent these duplicate entries occurring in the first place. But due to some mistakes, or the duplicates can get into properly designed table wherein this is due to changes in the business side, where after merging of two or more different systems or data from two or more different tables, we'll have this duplicate data in our tables. So in this session, we'll look at some of the ways to remove duplicate records from the table in SQL, right? So I've already created tables and inserted some values in it as well as some duplicate values also. So let us consider firstly the employee 4 table here. Let me just display the records. So use the select statement which is select star from employee 4. So let us execute this statement and we'll see the output. Right, now employee 4 table has various columns such as employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and finally department ID. Now there are different ways to delete the duplicate records, so we'll discuss one by one each. So firstly, we can delete the duplicate records using the group by and having function. So let us understand the syntax first. Now before we get into the execution part, you'll have to understand how to fetch the duplicate records from the database table, right? So for that, we'll use the following query as select first name, comma last name, which are basically the columns, and I'll use the count function, which will basically count all the duplicate values that are present in our employee 4 table. mention the table name, and we'll use the group by function. Group by, mention the column names you want to group, which is basically the first name and the last name, right? Having count, mention the star operator greater than 1, right? Let us now execute this statement and we'll see the output. So as you can clearly see in our resultant set, we have a total of 5 records such as Donald O'Connell, Jennifer Wallin, Michael Hastine, Herman Baer, and finally Alexander Hunold, where their records in the employee table have been repeated. For example, Donald O'Connell records have been repeated 3 times here. And similarly, we have Jennifer Wallen's 2, Michael Hastan's 2 times. Again, Herman's Baer was also 2 times. And finally, Alexander Hunold also 4 times. Right. Now that we have understood how to find the duplicate records that are present in our table, let us now understand how to delete. Now the query for that would be delete from, mention the table name, which is employee 4, where employee ID not in. So let us first understand the syntax, then I'll clearly explain how it actually works. So select, which is a subquery now, use the max function, mention the employee ID column name, close the parenthesis from employee 4, and you can use the group by function as well. So we'll group by the first name and the last name here. And close the brackets right there. So let us now execute this statement and we'll see the output. There is an error in the code which says you can't specify the target table employee 4 for update in from clause. Well guys, I think there is an issue in the backend. Maybe there's a error in the code, but I think the logic is correct here. So what this query actually does is it basically executes the inner query first, which is it selects maximum employee ID from the employee table, right? And it will display all those records. Now it will delete all the records in the employee 4 table whose employee is not in the maximum value, such as if I have, let's say 104 is the maximum value, and if I have 101, 102 or 103, which are basically the duplicate records. So it will basically delete all those records, right? So this is how it will delete the duplicate records in the SQL. I don't know why it is showing error, but we'll get back to you again with the right code. So this is one of the way to actually delete the duplicate rows from the SQL using the group by and having function. So let us now understand a different scenario where you'll use another method here. We can also delete the duplicate records using the delete join statement. Okay, so for that the query would be delete. Now I'll first let me write the query and then we'll understand how the syntax works. So delete, I'm taking an alias name for a table employee. So I'm taking as E1 from employee 4, which is the table, right, as E1, and I'm joining the table employee 4 as E2, where E1 dot employee ID is less than E2 dot employee ID, and E1 dot first name is equals to E2 dot first name. Right, so this is our query now. So let us understand how this actually works here, right? So now basically we are this query is referencing this employee 4 table twice, and therefore we'll use this table alias as E1 and E2, and after this executing the statement we'll get the following output as. So let us see the output and we'll understand. It's showing an error which is okay, employee underscore ID it is. So as you can see in our output, total 8 rows have been affected. Now let us understand how this query is working, right? Now I've taken 2 two similar tables here, that is basically the one table. I'm referencing it twice here. So basically it will delete all the rows which are less than the values that are present in the employee2 table here. So let me just display the values again so that we'll have a clear idea. Select star from employee4 table. So as you can see now, previously we had the repetition of certain records. For example, Douglas Grant we had, and similarly we had Alexander Hunold, and for similarly Herman Bernos. After execute this statement, we have only a single record where all the existing duplicate records have been successfully deleted. So in this way, you can use the delete join statement as well to delete the duplicate records from your table. Now the next method to delete these duplicate records is using the row number function. Now row number function is basically a SQL ranking function, guys, that will assign a sequential rank number to each record in a partition. Now when this SQL row number function detects any two identical values, or let's say duplicate values in the same partition, it assigns different rank numbers to both, and this rank number will be determined by the sequence in which they are being displayed. I know this might sound a bit confusing, so let us understand the query and see how it exactly works. So the query is followed as select employee ID, comma first name. So basically display all the columns that you want in your resultant table. Last name, mention the row number function, row number function over partition is the keyword, partition by is the keyword, and we are partitioning using the first name here, right? So mention the column name as first name, and similarly we'll also mention the order by clause, mention the first name again as, now let us give an alias name for this. Let's say we'll take it as row underscore num. Mention the table name, that is employees. So let us consider another table here which is employees 3. Right. So this is our query. So let us understand what exactly this syntax is all about. Now we are using the over keyword here, which basically is a clause which specifies the windows or set of rows that the window function operates, and the partition by and order by are the two possible clauses of the over clause. And next we have the partition by keyword, which is an optional clause in the row number function. It is basically a clause that divides the result set into partitions. Now the row number method is then applied to each partition, which assigns a separate rank number to each partition. And if the partition by clause is not specified, the row number function will treat the entire result as a single partition and rank it from top to bottom. And finally, we also have order by clause we are using here, which is the clause it allows the user to order the rows in the resultant set. So I hope you've understood this. So let us now execute this statement and we'll see the output. Right. Now as you can see in our resultant set, we have details of an employee, Alexander Hunold, whose employee ID is 103 here, which has been repeated for 4 times here, right? So in this way, the row number function will assign values in a sequential manner starting from 1. That is 1, 2, 3, 4. That is basically 4 different values. Now again, we do not have a repetition of this value. So again, it is mentioning, or it is assigning 1 as value for the next record. Now similarly, we have Bruce Ernest as only 1 record. So we have row number as 1. Now next we have Donald O'Connell, whose records are again repeated thrice here, right? You can see here. So the row number function assigns the values as 1, 2, 3. So similarly for all the rest of the records that are present in the table, it assigns the value in a sequential order on the number of times it has been repeated. So now that we've added the partitions and the row numbers to our resultant set, let us now understand how to delete these duplicate records. Now the syntax for that would be delete from employee 3, which is the table name, employee 3 where employee ID in. Now within the parenthesis, we'll write a subquery here, which is basically select all the employee IDs from, mention another subquery here, which is basically the previous query that we have written here. So we'll just write it again. Select employee ID, comma first name, comma last name, and mention the row number function over partition by is the keyword first name. Again, we'll use the order by clause for the first name again, and we'll give an alias name for this subtable, which is row num. From employee 3 table. And for this outer part of the query, we'll give another temporary name, let's say temp table, where row number is basically greater than 1. So what this query does is basically it will check all the values, and it will see that for all the values which is having row number greater than 1. For example, we have for Alexander Hunold, we have row numbers has 1, 2, 3, 4, right? So it will remain this the first record as it is, and it will delete the remaining records. For example, the records having Alexander Hunold as row number function 2, 3, 4 will be deleted, and similarly for Donald O'Connell 2, 3, the row numbers will be deleted. So let us now execute this statement and we'll see the output. It is showing an error again, so let me just make some changes. Well, the query is actually correct, guys. I don't know why it is showing the error here. Okay, I forgot to close the parenthesis here, right? So that was my mistake, sorry. So let's now execute this statement and we'll see the output. I3 3. I think the employee table name has been returned wrong, right? So let us execute this statement and we'll see the output now. So our query has been successfully executed, guys, and we can see that 13 rows have been affected. So let us now use the select statement again, and we'll see the records whether the duplicate records have been deleted or not. So select star from employee 3 table. Right, so clearly you can see that in a resultant set we have all the duplicate values that have been successfully deleted permanently. So in this way you can use the row number function as well to delete the duplicate records in your SQL table. We are going to learn what is pattern matching in SQL. For the execution part, let us jump into MySQL Workbench. So as you can see, MySQL Workbench has started, and on the left side you can see the SimpliCode database, which has various tables like crypto 2022, customer, department, new employees, Olympics, and etc. So before getting into the execution part, guys, let us understand how exactly the pattern matching works. Now remember, when you start typing something into Google search bar and it auto completes feature already completes your sentence, right? So what exactly is happening there? So Google is basically trying to accomplish is what is pattern matching. Pattern matching is basically checking whether a specific sequence of characters or token or a data or the other information that you're looking is existing in the database or not. So for that we use pattern matching in SQL. Now SQL pattern matching allows you to search for patterns in data if you don't know how the exact word or phrase you're finding is there or not. So this kind of SQL query uses wildcard characters to match a pattern. Now the like operator is basically used to find this specific pattern in the tables column. It is also used to compare columns within the specified values. Now together with the where clause, it determines if a pattern matches specific values in a table. It also uses some special wildcard characters such as the like percentage as well as the like underscore operator to find the specific pattern. So basically the like percentage sign is used to represent 0 or more characters, and the underscore sign is used to represent exactly one character, right? To get a clear picture of both these operators using the special wildcard symbols, let us look at some examples and see how they are executed and how it will return the values. So for that, let me just switch to another tab and let us consider the Olympics table to perform operations using the pattern matching in SQL. So let me just display the results from the Olympics table. So I'm using the select star from Olympics table. Right, so the Olympics table has various columns or fields such as ID, name, sex, age, height, weight, country, NOC, games, year, season, city, sport, and event, and also the medal that they have won. So firstly, let us discuss some examples using the like percentage operator, guys. So as we discussed earlier, like percentage operator basically returns one or more characters having certain patterns that we've mentioned in the condition in our query. So let me just take a first example here and we'll see how it gets executed. Now let's say if I want to fetch details of all the athletes who have participated in Olympic Games whose name starts with S. So in that case, the following query would be select star from Olympics where name like, and within the single quotes you have to mention the character that you are searching for, which is S, and mention the percentage symbol. So let us just execute this statement and we'll see the output. So it will basically display the results of all those athletes who have participated in the Olympics whose name starts with S. So if you want to further write a query in order to display in ascending order, you can use the order by function as well. So I'll use the order by name. So this will basically represent all the names starting from S and also the second character which will maintain in the ascending order. Like if you see Salim Abanos, and next we have Silvano Abba and so on till Stephen Anthony Bass, right? So in this way, if you want to display only the results using the first character, you can use this. Next, let us discuss another example. Now, you can use multiple characters also to find the patterns in order to fetch the data. Let's say if you want to retrieve the details of all the events in the Olympic Games whose name starts with, let's say, SA. So in that case, we'll be using the query as select star from Olympics where event like SA %. So let us execute this and we'll see the output. So we were talking about events, right? So we have events here, like various events. So let me just use the distinct so that we'll have only the event's name. Select distinct event and we'll see the output. Okay. So as you can see, we have a total of 5 records that starts with the characters SA, like sailing, women's, windsurfer, sailing makes 3% keyboard, and so on. So in this way, if you know the first 2 characters of the value that you want to search, then you can use the percentage operator by mentioning the first 2 characters here. That is, we have taken SA here. Right, so let us move to the next query. Let's say if you want to display the names of all those employees, sorry, all those athletes in the Olympics table whose name ends with letter or the character N. So in that case, you use the query as select star from Olympics where name like. Now, in order to get the details of all those athletes whose name ends with N, you have to first mention the percentage and then mention the character that you're searching for, which is basically N, right? So we'll execute this query and we'll see the output. So in our resultant set, you can see list of all those athletes whose name ends with A, like if you consider Arvo, Ossian, Alton, and similarly we have Juomati, Tapio, Altonen, and if you scroll down a bit, you'll find all those names of the athletes whose name ends with N. So you can use this percentage operator to find the names of all those athletes in the Olympics table that ends with N as well. Right, moving ahead, similarly you can also find the names of the name of the athletes in the Olympics table that ends with multiple characters. So now, other than names, let us take another example. Let's say if I want to display distinct records of the sports whose sports name ends with ing. So in that case, I'll use select star, or sorry, select distinct sport from Olympics where sport like percentage ing. So let us execute this statement and we'll see the output. So it will basically display the records of all those sports played in the Olympic Games which ends with the characters ing. So no matter what it has in the starting places, it should end basically with the ing characters. So we have various sports like speed skating, cross country skiing, swimming, sailing, alpine skiing, weightlifting, and finally wrestling. Oh, sorry, we have more than that. So basically it displays all those sports which have ing in the last place. So I hope you've understood this. So let us now understand another scenario where we'll use this percentage. Now if you want to display the records of all those athletes who have I or K, let's say IK in any particular order in their names. So in that case, you'll use the following query as select star from Olympics, a table name, where name like. So the name can start with any character. So I'm using the percentage. Now it should have only IK in between their name. So at any positions. And finally, I'll enclose in with the percentage. So it can be in second, third, or you can say fifth, sixth, but basically it should have IK characters in the name. So let us just forgot to mention the single quote. So let us execute this statement and then we'll see the output. Right, so as you can see, we have the resultant set which has, for example, if you consider Agnes Erika Anderson, she has IK in between her name. And similarly, Jan Eric, similarly, he has IK characters in middle of his name. And similarly, we have Mika Lauri, Aranika, Arvi Alec, Monica Ava, and so on. So even in this way, you can use a different scenario where you can understand and use the percentage operator. Well, let us now consider another example, guys. Let's say if you want to display all those countries where the Olympic the countries of all the athletes who have participated in the Olympics whose country name starts with C and ends with A. So in that case, the following query would be select star from Olympics where country like C percentage A. So what this basically does is it will retrieve all the records of the countries which has the letter C as its either first position and A as in the last position, and it can have any number of characters in between. So for that we are using percentage sign. So let me just execute this and we'll see the output. So if you can see in our output, we have different countries that start with C and ends with A. So let me just use this thing so that we can have a clear picture. So as you can see, we have China and Cuba, which are only two countries which have the letter C as it's in the first position and A in the last position as well. So this is another case where you can use the percentage operator sign as well. So, and finally, let us look another example of like before moving ahead with the underscore operator. Now, let's say if you want to find the details of all the athletes who have participated in the games in the 20th century, that is from 1900 to 2000. So not only the character values, you can even work on the numerical values as well while you're performing like operations. So let me just write a query. So select, I'll use the distinct name because we have repeated values of athletes. So, and also mention the year from Olympics where game like 19%. So it will basically display all the records whose the games that were played in the year 20th century, that is between 1900 and 2000. So let us just execute this and we'll see the output. Oh, sorry, I think it's games. The column name is games. So as you can see, it will display the records of all the athletes who have played various games in this year starting from 1900s to 2000. So if you want a more good looking query, you can use the order by so that it will sort the result in ascending order. So let us just execute this. So as you can see in a resultant set, it is displaying the records starting from 1900 and so on up to 1998. So in this way, you can use the numerical values also to find certain patterns as well. And you can also use the AND or operator, AND or operator as well. So let us consider another example there. Now let's say if you want to fetch the details of all these athletes who have taken part in various Olympic games, be it summer Olympic games or winter Olympic games, and the sport that they have participated is basically starts with the letter B. So in that case, what we'll do is we'll add game section as well, which is a column, mention the AND operator and sport like percentage B. So what it does is basically displays all the records of the athletes who have taken part in all the Olympic games, be it summer or winter Olympic games in the 20th century, that is from 1900 to 2000. And also it will filter the records wherein it will only display the sport which starts with the letter B. And similarly, we'll do the order by year. So let us just execute this statement and we'll see the output. So as you can see, it is displaying me the record of all those athletes who have taken part in various games starting in the from 1900s. We have 1924, 1952 and so on up to 1998. So in this way, you can also use the AND operator basically to fetch the records using the percentage operator. So I hope you've understood till now how we use the like percentage in order to find certain pattern in our values that are present in our tables to fetch those records. Let us move ahead and discuss some examples by using the like underscore operator. Right, as we discussed, like underscore operator basically returns exactly one character that we specified. So let us just understand with an example here so that you'll have a clear idea. So let's say if I want to fetch the details of all the names of athletes in the Olympics table whose name starts with J and have a total of, let's say, 5 characters. So in that case, the following query would be select star from Olympics is the table name where name like, mention the single brackets, and we know that their name starts with J and they have a total of 6 characters. So we'll write underscore 5 times, 1, 2, 3, 4 and 5. So let us see the output. So as you can see in a resultant set, we have no records of the athletes whose name starts with J and has a total of 6 characters. So let us take another example. Let's say if you want to find the details of the cities where the Olympic Games have played, which basically starts with the letter B and has a total of 6 characters, right? So in that case, what we'll do is select star from Olympics where city like B and mention 5 underscores because it has a total of 6 characters. We already mentioned the character B in the first place, so we'll have 5 underscores. So let us just execute this and we'll see the output. So in a resultant set, we can see Berlin is basically the city. I think it is only one and only the city that they have played in, which has the letter B in the first position, and it has a total of 6 characters. Now, since you don't know the exact characters that are present in what positions, you're basically using the underscore characters to mention that. Right, I hope you understood this, guys. Let us take another scenario so that we have a more clear picture of how the underscore works. Now, we'll use this underscore in the last position, wherein we'll display the records of all the countries of the athletes that they have taken part in the Olympic Games, whose country name ends with N and has basically 6 characters in total. That is 5 characters we have to mention as underscore, and we will have the N as the last letter. So select star from Olympics where country like, so mention a total of 6 and mention the last letter which ends with A. So let us execute the statement and we'll see the output. So these are basically the, so let me just use the distinct so that we'll have only the country names in our result table. So basically Cameroon and Pakistan are basically the 2 countries that the athletes belong to, which have a total of 7 characters and has N in the last position. So as you can see, Cameroon and Pakistan are both those countries. Right, so let us discuss another example, a final example before we move on to our next scenario. So finally, let's say if you do not know the name of the, let's say, the sport that you want to retrieve, but you know it has a total of only 6 characters. You don't know the starting letter, you don't know the ending letter, but you know that it has at least, or let's say, 6 characters in total. So in that case, we'll use select distinct. So we'll display the sport. So I'm taking the sport column from Olympic Games, Olympics, where sport like, so mention 6 underscore values, 1, 2, 3, 4, 5, 6. So let us execute the statement and we'll see the output. So basically we have 5 records of the sports that are played in the Olympic Games, which have a total of 6 characters, which is hockey, rowing, bowling, diving, and tennis. So in this way, you can use the underscore operator without mentioning any characters or values at all to find the actual or the value that you're searching for in your table. So that is how you use the like underscore operator, guys. Now we have another case wherein we'll use both the like percent as well as the underscore values all together in order to retrieve the data from our table by specifying certain patterns. So let us understand this with an example. So let's say if you're trying to fetch the details of all the countries of the athletes, which whose country name starts with S and has at least 3 characters. I'm using the word at least because it can have any number of values after the first character. So let me just explain this with a query here. Select star from Olympics where country like, now the country name should start with S and it can have basically 3 characters. So I'm using the percentage sign as well. Now I'm not telling it should have exactly 3 characters. It can have at least 3 characters. That is, it can have 4, 5 or even 6. So let us just execute the statement and we'll see the output. So where is this? The country, right? So we can see in a resultant set Spain is a country which starts with S and have at least three characters in total, and similarly we have Soviet Union as well. So in this way you can use both underscore as well as the percentage operator. So let us just understand with another example here, guys. Let's say if you're trying to fetch the details of all the events from the Olympic Games that were played, which basically has M in its third position and can have any number of characters. So in that case, the following query would be select star from Olympics. Sorry, we are just selecting the event, right? So I'll mention the event. Select event from Olympics where event like. Now I said the character M is present at the third position. So first I'll mention two underscores. Next I'll mention the M character, and then finally I'll mention the percentage, so that it can have any number of values after the character N. So let us just execute this statement and we'll see the output. So it will basically retrieve all the events that are played in Olympic Games, which has M in the third position. So as you can see, gymnastics men's individual all round, similarly gymnastics men's team all round, floor exercises, horse world, and all this have M in the third position, and basically it has any number of characters, that is a total number of characters. So right, I hope you're following with me and you're understanding this. So let us consider another example. So let's say if you're trying to retrieve the countries that the athletes are belonging to, where the country name has A in the second letter and ends with N. So in that case, what we'll do is I'll write another query, which is select star from Olympics where country like. So I said we have A in the second position, so we do not know what is present in the first place. So I'm just mentioning an underscore, and then I'm mentioning A, and then I'm using percentage because we have no restriction here. It can have any number of values. Now the only criteria is that it should end with N, right? So we'll just execute this and we'll see the output. Okay, it is displaying all the records, right? So let's just use the distinct country. So as you can see, we have a total of 4 records, which are basically Typhoon, Cameroon, Bahrain, and Pakistan. Now, if you clearly look into this resultant set, we have A in the second position. You can see, right? So we have A in the second position, and it is having n number of characters, which is of no limit, and the only condition we have specified is it should end with N. So in all these records, the country names are ending with N. So in this way, you can use the percentage and percentage and the underscore to specify this kind of pattern as well. So I hope you've understood this, guys. So finally, let us look at another example so that we can wrap this session finally. So let's say if you want to display records of various sports that are played, which can have any number of characters, but the last but one character should be N. That is, it should contain letter N, or basically the penultimate character should end with N. So in that case, the following query would be select distinct sport from Olympics where sports like. So I hope you understood the question. The question is, this sport can have any number of characters, but the only condition is the last but one character should be N. So I'll first mention the percentage, that is, it can have any number of characters before, and after the percentage, I'm mentioning N, which is basically the last but one character, and I'm mentioning an underscore, that is, it can have any number of any value in the last place, that is, it can fill any character in that place. So let's just execute this statement and we'll see the output. Okay, sport, sorry, it is just sport, not sports. So in our resultant set, you can see that we have various sports which basically has N in the second last position. So you can see in speed skating, in cross country skiing, swimming, sailing, and so on. In all these values, we have n at the last position. So in this way, you can use both percentage as well as underscore to find patterns in your data table as well. So, and similarly, guys, we have the not like operator to find the pattern matching as well. So let me just help you with this example. So let's say if you want to find the age of all the athletes who are not in the age of not in the age group of 20, right? So in that case, what I'll do is select star from Olympics, where age, use the not like keyword and mention 2%. So it will basically omit all the values or the values of all the athletes whose are ranging in the age group of 20 to 30. So let us just execute this statement and we'll see the output. We'll also use the order by, so that we'll have in the ascending order by age. Right, as you can see, the resultant set has all the ages of the athletes starting from 16, 17, 18 and 19. And if you clearly observe here, after 19 we have 30. So basically it is omitting all the values that has 2, or that is the athletes age is lying in the range of between 20 and 30. So in this way you can also use the not like values, not like operator to omit the values that in the pattern matching as well. We will be discussing about triggers in SQL. Firstly, let us discuss the agenda for today's session. We'll start the tutorial by understanding what are triggers in SQL, and then we'll go through why we use triggers, and after that we'll see different types of triggers used in SQL, and after that we'll be discussing various operations used with triggers, and then we'll get into the execution part in MySQL Workbench using various examples. And finally, we'll wrap the session by discussing some advantages and disadvantages of triggers. So without any further ado, let us jump straight into today's topic. So firstly, what are triggers in SQL? Now, triggers is a database object which fires when an event occurs in a database, or you can say a trigger is a piece of code executed automatically in response to a specific event occurred on a table in the database. Now, triggers, as the name suggests, are stored procedures. Now, what are stored procedures? Means procedures are basically functions which contain SQL statements which are stored in database and can return some output which are executed or fired when some event occurs. Now, a trigger is always associated with a particular table, and if the table is deleted, all the associated triggers are also deleted automatically. Now, the triggers are executed in response to certain events like insert, update, or delete in a particular table. Now, a trigger is invoked either before or after the following events from the DML commands, like through insert when a new row is inserted, or through an update command when an existing row is updated, or through a delete command when a row is deleted. So when you issue an insert, update, or delete statement, the relational database management system fires the corresponding trigger. And also these triggers helps in maintaining the integrity of the data by changing the data of the database. Let us now understand the syntax of triggers. Now we can create triggers for various types of operations as discussed above, and we'll mostly focus on DML triggers as these are the most commonly and extensively used triggers, and also at the same time most important. So a DML trigger can be created using the following syntax, which is followed as create trigger, trigger name, before, after, instead of, insert or update or delete on table name for each row, begin, trigger body, end, /. So let's just discuss the different parts of the syntax clearly. Now we have the create or replace trigger, trigger name in the first line, where we give the name of the trigger we are creating or updating. Here, trigger name is to be replaced by the name you want to have for your trigger in your database. Now it can be of any name as per your choice. Next, we have the before, after instead of keywords. Here we define when the trigger would run, that is before or after the DML operation. For example, if we want a trigger to be executed after insertion to a table, we will consider after insert here. Next, we have various DML commands like insert or update or delete. This is the operation or event we have to define which will trigger a procedure to be executed. If we want a procedure to run after a deletion happens on the table, then we'll consider writing delete there. Next, we have on table name. Here we have to specify the name of the table on which we are attaching the trigger. And next we have for each row keyword, where this line specifies that the procedure will be executed for each one of the rows present. Here we can set a condition for which rows to be impacted. This part is optional though. In case we don't use this, a trigger shall convert to a statement level trigger rather than being a row level one. So we'll discuss about that later. So next we have the when condition, which mentions some condition basis of which the trigger will run. In absence of when condition, which is again optional, you can expect it to run for all the eligible rows. So this is very important as this will control which rows the trigger must run. And finally, we have the trigger body, which is the main logic of what to perform once the trigger is fired. In the previous statements, all we defined is when this trigger will be fired. But here we have to define what to do after the trigger is fired. So this is the main execution part of the SQL code. And we end the syntax with end double slash. Right, moving ahead, why we use SQL triggers. Now, since a trigger resides in the database and anyone who has the required privilege can use it, a trigger lets you to write a set of SQL statements that multiple applications can use. So it allows the user to avoid redundant code when multiple programs need to perform the same database operations. SQL triggers also maintains complex column constraints. Now what I mean from that is it helps in maintaining the integrity constraints in the database tables, especially when the primary key and foreign key constraints are not defined. And it also helps in maintaining the track of all the changes like updation, deletion and insertion that occur in the database table. Triggers also increase the performance of SQL queries because it does not need to compile each time the query is executed. Alright, moving ahead, let us now discuss the types of triggers in SQL. Now, triggers are of two types in general according to the SQL standard language, which is row level trigger and statement level trigger. Now, row level trigger, which is activated for each row by a triggering statement such as insert, update or delete. Now, for example, if a table has inserted, updated or deleted multiple rows, the row trigger is fired automatically for each row affected by this insert or update or delete statement. And next we have the statement level trigger, which is fired once for each event that occurs on a table, regardless of how many rows are inserted, updated or triggered. Now further we have 6 types of triggers based on the events of occurrence of the triggers through the DML commands that are invoked and at the time of when they are executed. So we can define the maximum of 6 types of actions or events in the form of triggers, which is before insert, after insert, before update, after update, before delete and after delete. Let us now discuss about them in detail. Now first we have the before and after insert trigger. The before insert triggers are used to modify or check record values before they are saved to the database, whereas the after insert triggers are used to modify other records and access field values set by the system. And the syntax for before and after insert trigger is followed as delimiter, create trigger name, before or after is the keyword we have to mention prior to the insert name, on table name for each row begin, mention the body of the trigger and mention the end keyword and end with the delimiter. Next we have the before and after update trigger in SQL. Now before update triggers are invoked automatically before an update event occurs on the table associated with the triggers, while after update trigger is invoked when the operations on row is under execution after an update operation on the database. Now the syntax is also same. Instead of the insert, you have to just replace it with the update keyword with the before and after keywords as well. Now firstly we'll specify the trigger name that we want to create and it should be unique within the schema. Next we'll specify the trigger action time, which should be before update or after update. So this trigger will be invoked before each row of alterations occurs on the table if you use before, and similarly with the after keyword as well. And third, we'll specify the name of the table to which the trigger is associated. So it must be written after the on keyword. And if we do not specify the table name, a trigger would not exist. Finally, we'll specify the trigger body that contains a statement of execution when the trigger is activated, where you can mention the different condition using the when keyword as well. Now we cannot update the old values in a before update trigger we can change the new values as well, which we'll discuss while we are executing the code in MySQL Workbench, so that you'll have a clear idea. And finally, we have the before and after delete trigger as well. Before delete triggers are fired automatically before a delete event occurs in a table, and after delete triggers are invoked when the operations on the rows is under execution after any delete operation on the database as well. Now the syntax is also similar to that of previously to that of insert and update, which is create trigger name before after delete on table name for each row, and then mention the trigger body. So in this way, you can apply various triggers on your database. So to understand this in a more better way, let us jump into MySQL Workbench for further execution part. So as you can see, MySQL Workbench has started, and first let us discuss how to create a before insert trigger now. Now as discussed earlier, before insert trigger in SQL is invoked automatically whenever an insert operation is executed. So let us discuss how to create a before insert trigger with its syntax and an example. Now, in order to create a trigger, you have to first create a new table and then insert values into it to perform a trigger operation. But we already know how to create a table and insert values into it. So let us just consider an already existing table. Let's say new employees. So I'll just display the values. Select star from new employees. So the new employees table has various attributes such as employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and department ID. Right. So let us now run the before insert syntax. So first we have the delimiter here. Now when we are writing SQL statements, we generally use the semicolon, right, to separate two statements. Now since a trigger is a stored procedure which consists of multiple statements separated by a column. So if you're using MySQL to define a stored procedure like trigger that contains semicolon characters, it will not treat the whole, like the stored procedure, as a single statement, but many statements. Therefore, you have to define the delimiter temporarily so that you can pass the whole, the body of the trigger as a single statement. So typically we are just separating the statements using the double slash here. So delimiter. Now we have to write the actual syntax for the before insert trigger, which is create trigger, which is the keyword I'm using. And let us take the trigger name as, let's say, before insert. You can take it as per your own choice. Insert, before insert is the keyword on the table, that is new employees. Now I'm applying trigger for each row, so I'm specifying for each row. Now here comes the main part where you have to mention the condition. Now the trigger that I'll be invoking is, let's say now we have department IDs here, right, which are having values like 10, 20, 50, 100, 60s and 100. So if you notice here, we have the department IDs in the name in the multiples of values of 10. So I'll be creating a trigger whenever a new user is trying to insert values into their table as department ID which is less than 10. So in that case, I'll set the new department ID as 0. So the query would be if new dot department ID is less than 10, then set new dot department ID equals to 0. So mention the end if and end double slash. Now you might get a doubt here, like why I'm using new dot department ID. Now triggers allows access to values from the table for comparison purposes using the new and old keyword, and this availability of keywords will also depend on the trigger event which you're performing. Now, since you're checking or modifying a value when you're trying to insert data using the new dot column modifier, which is available, whereas if you're trying to insert old values, that is using the old.column name value, does not exist for an insert statement because there is no information exists in its place beforehand. So that is the reason I'm taking the new keyword here. So we have created our trigger. So let's just execute this statement and we'll see the output. Okay, there is an error. So let me just. So it says that trigger already exists. Might be have taken it already. So let me just change it and keep it as department insert. So as you can see, our trigger has been successfully created. Now let us consider the new employee table again and let us insert some values to understand how this works. So I'll be inserting some values into the table. So I'm using insert into new employees values. So mention the employee ID, let's say 288, comma, mention the name of the employee, first name, let's say Carl, and the last name as Haddon. Next we have email, so let's take C Haddon. Next we have phone number, just type a random number. Next we have hiring date, so let us take as 15th June 2009. Next we have job ID, let's take SH clerk as our job ID. Next we have salary, let's take 35,000. Next manager ID, let's take 125 or 126. Next we have the department ID. So I'm taking the department ID here as 7. Right, so let us just execute this statement and we'll see the output. So our record has been inserted. So let me just retrieve the values again. So if you scroll down a bit, we have our new details of our employee having employee ID as 288, whose name is Carl Haddon. And if you slide a bit, and you can see that since we have inserted the department ID value as 7, and the trigger will automatically be created here, which is department ID is less than 10, right? So automatically it has changed the value into 0. So in this way you can use the before insert to create a trigger in your table. Right, so I hope you've understood how to create a before insert trigger. Let's move ahead. Let us now discuss how to create an after insert trigger. Now, after insert trigger in SQL is basically invoked automatically whenever an insert has already occurred on the table. So let us just understand this with an example. So let us consider the customer tables here. So let us just display the values in the customer table. So a customer table has 4 attributes, which is customer ID, customer name, age, address, and we have a total of 5 records. So let us understand how this after insert trigger works. Now we have customer ID starting from 101 and 105. Now basically I'm going to create a trigger like whenever a customer's details has been inserted, which is having customer ID more than 200. So in that case, I'll be inserting this into another table instead of this customer table. So for that, let us just create another table. So you can create a table using this icon here. So I'm creating a new table, which is customer new, and we'll create the columns as well. So the column names need not be identical. It should basically have the same data type, even if it's not having the same column names. So ID, and then we have name of the customer, and then we have the age, and finally we have the address. Right, so let us just apply and we'll create a new table. Alright, so we have created a new table which is customer new here. So let us now write the syntax for after insert. So I'm again using the delimiter, and let us create a trigger now. Create trigger. So I'm taking the trigger name as again after insert. You can take it as per your own choice. So since we're creating after insert, mention the after insert on the customer table for each row. Now begin. So let us now create a trigger here. So the condition that we have taken is if new dot cust id is greater than let's say 200. So in that case, insert into customer new values new dot cust id comma new dot customer name, and then we have new dot age comma new dot address, right? So let us just close this, and we have the endif double slash. So let us just execute this query and we'll see the output. So our query has been successfully executed. Let us now try to insert some values into the customer table. So I'm using the insert into customer values. So customer ID, let's say I'm taking 108. Name of the customer, let us take Priya. Let us take the age as 24 and address as Pune. And similarly, let us insert some more values. Let us now take 204 as the customer ID, name as Harsh, and age as 27, and address as Chennai. Let us insert a final record, which is let's say 180 109, comma name as Sam, age 24, city let us take Hyderabad, close the brackets, and let us insert one more final record. Let us take 214 as the customer ID, and the name will be John, age 25, and city will be Mumbai. Right, so we have inserted the values into our customer table. So as you can see, 4 rows have been inserted. So let us just display the records again. So as you can see, we have 4 new records of the customers having customer ID 108, 109, 204 and 214. Now let us see whether our trigger has been created or not. So let us display the values from the customer new table now. Select star from customer new. So as you can clearly see that the trigger that we have applied to our table is whenever the customer ID exceeds 200. Now in this case we have 2 IDs of the customers, which is 204 and 214. In that case, the trigger will automatically insert new values into the new table instead of the previous table, which is customer. So in this way, the after insert trigger works. Alright, moving ahead, let us now discuss about the before update in trigger. Now before update trigger in SQL is invoked automatically whenever an update operation is performed or fired on the table associated with that trigger. So let us just understand this with an example here. So let us just consider again the new employees table here for our reference. Added another attribute which is bonus in our table. Now basically the trigger which you are going to create will be of this sort, wherein if you're updating the salary of the employees, let's say if you're updating the salary of employees whose salary is greater than 50,000 or 40,000, then we'll set the bonus value as 5,000. And if the salary is less than 40,000, in that case their bonus will be 3,000. So let me just write the syntax so that we'll have a clear understanding of it. So we'll use the delimiter again. Let us create a trigger update bonus. So we are creating before update trigger. So I'm writing the before update keyword on new employees. For each row, since we're performing on all the rows, mention the begin statement and mention the condition now. So the condition is basically is new dot salary is greater than 40,000. So in that case, the new bonus value will be equals to 5,000. So else if the salary new dot salary is less than 40,000, so in that case we'll set the bonus value as 3,000. Set new bonus equals to 3,000. So mention the semicolon and mention the end if, since we have used two end if statements, so we'll mention end if 2 times before we close our statement here. So let us now execute this statement and we'll see the output. So our query has been successfully created here, guys. Let us now update the values in our new employee table. So let us write the update statement here. So I'm updating the new employees table. So update new employees, set salary equals to let's say 45,000 for only limited employees. Let's say whose employee ID is more than 200. So I'm just taking a reference here, or just an example or a scenario, so that we'll have an understanding on how this before update trigger works. Whose employee ID is greater than 200. So right, let us just execute the statement. So as you can see, 7 rows have been affected. So let us now display the new employees table again. So I'm using the select star from new employees. Alright, so let us move aside and see. Now, as you can clearly see that now employees who are having employees ID more than 200, which you have taken in our query. Now, if you can see, employee ID of Michael Haston is 201 and Pat Fay 202, and for Susan Marvis we have 203 and so on. So for all those employees, we have a bonus attached to their salary, which is 5,000, which is basically the trigger that we have created. That is, if the salary is more than 40,000, in that case we'll invoke a trigger where it will add bonus of 5,000 to all those employees. So in this way, before update trigger works in SQL. We are going to discuss what exactly is auto increment in SQL and how to use it. So without any further delay, let's get started. Let us now head into MySQL Workbench for execution part. So as you can see, MySQL Workbench has started. Let me just enter the password to enter into it. Alright, we have logged in into our MySQL Workbench. So before getting into the execution part, let us just quickly understand what is auto increment. Now the auto increment in SQL is basically a feature that is applied to a field so that it can automatically generate and provide a unique value to every record that you enter in an SQL table. Now this field is often used as the primary key column, where you need to provide a unique value for every record you add. However, it can also be used for unique constraint columns as well. So let us now understand this with an example here. So let me just create a new table so that we can implement it. So let us create a new table here, which is, let's say, orders. Open the parenthesis and let us now mention the columns that you want to create. So let us take the first column as product ID, and product ID will be of int, and we'll make sure that it is not null. And then if you're working on SQL, it applies an auto increment field with the keyword as auto increment. So we'll write it as auto increment, and then comma, mention the next attribute. Let us take as customer ID in our orders table, and I'm again giving int as the data type for this. And again, we cannot have customer ID as null, so I'm mentioning the constraint not null. Next, I'm mentioning the product name, that is the list of orders that the a customer has placed and the name of that product. And here I'm taking the data type as varchar, and I'm taking it size of up to 20. Next, let us take, let's say, quantity, and let us take it as in data type. And finally we'll take price, which will be again of varchar of 20 size. So that's it. Mention the comma and let us close it. So let us just execute this statement. There is an error. I don't know, guys, why it is showing as error. Let me just check it once. So I think there is an error. So let us just create a table using this icon here. So orders new, and let us mention the column names here, which is customer ID. Sorry, first one will be product ID. Product ID. We have customer ID, and then we have product name, and then quantity, and finally we'll take the price here. All right. So let us give the product ID as the auto increment. We can click on this auto increment value where you can find it as AI, and let us now execute. Click on apply, and our table will be created. So as you can see, our table has now created. So let us now just insert some values into it, and we'll see the output. So mention the insert into, mention the table name, that is orders. Now, in order to insert the values into it, you need not write the product ID column here. So we'll just directly write the customer ID, and we'll see how the auto increment directly works. So customer ID, next we have product name, next we have quantity, next we have price, and mention values and insert some values. So customer ID, I'll just take it as 101. Next, product name, let us take as AC. For quantity, let's say 2, and price will be 60,000. All right, and similarly, let us insert another value here. I'm taking the next order customer ID as 102, and we'll take the next product as cooker. Enclose in my single brackets. Next, we'll take quantity 1, and price will be 25,000. Sorry. And finally, let us take another example. Let's say 102, 103, comma
let's say phone as our next product name, and we will take the quantity as 3 and the price will be 90,000. Alright, we are good to go now. Let us execute the statement and we'll see the output. Sorry, orders, new rate. So as you can see, 3 rows have been inserted. So let me just display the values from it. So as you can see, in the product ID column where we haven't mentioned it in our insert statement, and it is automatically generating the values like sequential starting from 1, 2 and 3. Now you can also make an auto increment in SQL to start from another value with the following syntax using the alter table as well, guys. Now let's say if you're working on an employee table, or let's say if you are working on any other student table, for example, in that it might be of different digits, like the employee ID can be of 5 digits or 6 digits. So in that case, you have to change the order in which you want to create and increase the employee IDs, right? So in that case, what we'll do is we'll write alter table and then mention the table name. So we are taking orders new table here and mention the auto increment keyword and set from where you want to start it. So let's say if I want to start it from 12,001, right? So let us just execute and we'll see the output. So our query has been executed. So let us now insert some more values into our table and we'll see how it goes. So let me just now I'll add some more values like 107 comma the product name as cooker, let's say the quantity 2 and the price will be 50,000. Similarly, let us take another record, let's say 109 comma let us take as tablet as our product name, and then we'll mention the number of quantity as 4 and price will be 1,50,000. Alright, so let us just execute the statement and we'll see the output. So 2 rows have been inserted into a table successfully. So let us just call the orders new table again. So let me just use the select statement, select star from orders new. So as you can see, now there are 2 records that we have inserted, which is of customer ID 107 and 109 and the orders they have placed as cooker and tablet. Now if you look at the product ID, we have started their product ID from 12,001 and sequentially it will increase the value by 1. That is, now we have 12,001 and next we have the 12,002. So in this way, you can use the auto increment in SQL to set up values in order to make them automatically updates for your database. Now instead of writing every time, you can just simply mention the auto increment and it will do the job. And if you're working on various other databases like SQL Server or even Oracle, in that case the syntax will change. In that case, what you have to do is in the create statement you have to take the keyword as identity and mention the values from which your column name column values will start. Let's say I'm taking as 100 comma and how much values you want to increment. Like let's say if I mention 1, it will increase the value by 1, like 100, 101, 102 and so on. But if I take it as let's say 5, then it will start from 100. Next the value will be 105, 110 and so on. So in this way, if you're working on various other databases, you can use this as well. We are going to discuss about normalization in SQL. Firstly, let us go through the agenda for today's session, guys. We'll start the tutorial by understanding what is normalization in SQL, and then we'll understand why do we need normalization. And after that, we'll discuss various types of normalization used in SQL.
which are basically different normal forms such as first normal form, second normal form, third normal form, and BCNF, which is Boyce Codd normal form. And finally, we'll wrap up the session by discussing some advantages and disadvantages of normalization. So without any further ado, let us just dive into today's topic. Alright, so what is normalization in SQL? Normalization is the process to eliminate data redundancy and enhance data integrity in the table. Normalization also helps to organize the data in the database, and it is a multi-step process that sets the data into tabular form and removes all the duplicated data, that is the repeated data in the relational database tables. Normalization organizes the columns and tables of a database to ensure the database integrity constraints properly execute their dependencies. So it is a systematic technique of decomposing tables to eliminate data redundancy and various other undesirable characteristics. Now, to better understand this concept, it simply means to bring something to its normal state. Now, from that, what I mean is the columns and tables are organized to ensure that the data integrity constraints are appropriately executed with their dependencies in normalization. So normalization in SQL is mainly used to reduce the redundancy of the data, since SQL is a language that interacts with the database to start any interactions with the data in the database. The data which is present in this database should be in the normalized form before it is processed further. So that's why normalization in SQL improves the data distribution in the database across. Next, why do we need normalization? Now, as discussed earlier, normalization is used to reduce data redundancy, which is the most important thing. So it provides a method to remove the following anomalies from the database and bring it to a more consistent state. Now, a database anomaly is a flaw in a database that occurs because of various reasons such as poor planning and redundancy. Now, there are various reasons such as insertion anomalies, which occurs when we are not able to insert data into a database because some attributes may be missing at the time of insertion. Next, we have updation anomaly as well, which occurs when the same data items are repeated with the same values and are not linked to each other. And finally, we have deletion anomaly, which occurs when deleting one part of the data deletes the other unnecessary or necessary information from the database. So that is the reason we need normalization. So if I put them into a nutshell, these are the main objectives of normalization, guys. So the normalization removes duplicate data and database anomalies from the relational database. It also reduces redundancy and complexity of database by clearing unwanted records or values in the database. It is also used to avoid creating and updating any unwanted data connections and dependencies. Now, if you're working on multiple tables, there may be a chance of unwanted connections. So normalization prevents that. It is also used to optimize storage space as well, guys. Now, you don't want unnecessary or repeated values in your database tables, right? So to organize and optimize the storage space, we need normalization. And finally, isolation of data is also maintained. Now, a good design database states that the changes in one table or field should not affect each other. So this can be achieved through normalization. So these were some of the important characteristics of normalizations and why we need it. Alright, moving ahead, let us now discuss some different types of normalization in SQL. Now, there are 4 types of normal forms that are usually used in relational database, as you can see in the following figure. The first one is first normal form or 1F. Next, we have second normal form or 2NF. Next, we have third normal form or 3NF. And finally, we have Boyce Codd normal form. Now, actually, we divide the normalization process into a set of normal forms. So a normal form is nothing but a form of a table that follows some, let's say, rules or regulations that prevent the above anomalies that we have discussed earlier to some extent. So let us discuss about them in detail and see how they are different from each other and understand why they are important. So first, what is first normal form or 1NF? Now, a table is referred to as being in its first normal form if atomicity of the table is 1. Here, atomicity states that a single cell cannot hold multiple values. It must hold only a single valued attribute. The first normal form disallows the multi-valued attribute, composite attributes and their combinations. I hope this is quite a bit confusing, so let us just understand the first normal form with the help of an example. So these are the two conditions which I have already discussed. That the conditions for a table to be in first normal form is that every table should contain a single value, and each and every record must be unique. Alright, let us understand with an example. Now in the student table, let's say you can see the course column has certain values. So if you look at some of the courses and assigned to each student, we have more than one column. That is, the course column has two values. Thus, it does not follow the first normal form. Now if you use the first normal form to the above table, you can get the below table as a result. If you look at this side, the second table in that, we have basically divided the record into two parts. That is, Harsh, whose roll number is 1, who has enrolled in courses SQL and Java, which we are basically dividing into two records separately. That is, Harsh 22 SQL course and similarly Harsh 22 into Java. And similarly, we have for Kunal as well, who has enrolled for courses C and HTML, and also we have Sanya, who has enrolled for Python and SQL, which we have basically separated into two different records. So by applying the first normal form, you can achieve atomicity, and also every column has unique values. So that was first normal form, guys. Let us now move into the next normal form, which is second normal form. So the second step in a normalization is basically 2NF, or the second normal form, which is basically an additional layer added to the 1NF. So a table or a relation is in 2NF only if the table should be in first normal form. That is, it should satisfy all the properties of the first normal form, while the relation's every non-prime attribute depends on every candidate key as a whole. So it should meet all the rules, and every non-key attribute is fully dependent on the primary key. So I hope this is a bit challenging and confusing. So let us again understand this with an example here. Alright, now the second normal form states that there shouldn't be any partial dependency. Partial dependency is nothing but if a proper subset of a candidate key determines the non-prime attribute, then it is called a partial dependency. So let me just explain you with an example here. Consider this student table here, which has student ID, project ID, student name, and project name here. Now in the above table, if you look at clearly, we have partial dependency. Let us understand how. Now the prime key attributes here are student ID and project ID, and as stated, the non-prime attributes, that is student name and project name, should be functionally dependent on part of a candidate key to be partially dependent. I hope you've confusing between the keys, guys. So if you want to learn more about SQL keys, we have a dedicated and a separate video on our channel, so make sure you check that out. So coming back to the second normal form, so the student name can be determined here by partial dependent. So therefore, the student project relation, the table violates this 2NF in normalization and is considered a bad database design. So to remove this partial dependency and the violation of 2NF, we have to further decompose this table in order to satisfy the property of second normal form. So let us now understand how can we do that. Now basically, I am converting this student table into two separate tables, which is student info and project info. Now the student info table has the student ID, project ID, and the student name, whereas the project info has project ID and project name. Now a student name can be identified separately with the help of student ID. So it is uniquely identifying every record of the student name using the student ID. Hence the condition has been satisfied here, and similarly we have the project info. With the help of project ID, we can get the name of different projects that are allotted to students. So now the relation is in second normal form in the form of a database normalization using the second normal form. I hope you understood that, guys. So moving ahead, let us now understand what is third normal form. Now it is a normalization level in DBMS similar to that of 1NF and similarly 2NF. So a relation is said to be in third normal form in SQL when it is in the second normal form, but no transitive dependency exists for a non-prime attribute. So let me just clearly explain you again. Now a given relation is said to be in its third normal form when it is in 2NF. That is, it should satisfy second normal form properties. That is, ultimately, indirectly, it should satisfy first normal form as well, but has no transitive partial dependency, meaning when no transitive dependency exists for the attributes that are non-prime, then the relation can be said to be in 3NF. So let's say in simpler words, if I say it should be in 1NF or 2NF, when none of the non-primary key attribute transitively depend on their primary keys, then we can say that relation is in third normal form of 3NF. So we can say that a relation is in third normal form when it holds any of the given condition in case of functional dependency that is non-trivial, where P, let's say X relates to Y, where X acts as a super key and Y acts as a non-prime attribute, meaning every element of Y forms a part of a candidate key. So let us understand this with a simple example, guys, so that you will have a clear understanding of that. So for that, I'm taking another table, which is employee ID, employee name, department name, city, zip code as its attributes. All right. Now, the super key in the table mentioned above can be candidate ID plus candidate name, or else candidate ID, candidate name, and candidate, let's say, zip code, and so on. Now, the candidate key here is basically the employee ID because it is uniquely identifying each and every record. So if you look at the non-prime attributes, all the attributes in the table mentioned above are non-prime instead of the employee ID, right? So notice that employee ID and the employee city that the employee belongs to are dependent on candidate zip code, and the employee's zip code, and employee zip code is dependent on the employee ID. Here all the non-prime attributes like the city of the employee and employee's state are dependently transitively on the super key, which is employee ID. So the transitive dependency here would violate the rule of the third normal form. Thus, we must move the employee's city and the employee's zip code to a new table of, let's say, into another table, which is zip info. So if you look at this resultant table where I have segregated the original table, which is the employee table, into three different tables here, which has the first one is employee info, which holds the employee ID, employee name, department as the attributes and its information. And in the second table, we have department ID and department name separately. And finally, I'm categorizing the cities based on their zip codes, that is into zip info table. So in this way, you can use the third normal form to perform the normalization using the 3NF characteristics. Alright, let us now move into the final normalization, which is BCNF. Now, applications of general definitions of 2NF and 3NF may identify additional redundancy caused by the dependencies that can violate one or more candidates key in a table. So, however, despite these additional constraints, dependencies can still exist that will cause redundancy to be present in 3NF relations. So this weakness in 3NF resulted in the presentation of a much stronger normal form called Boy's Codd normal form, or simply BCNF. So it was initially started, it was coined by Dr. H. Codd in 1974. So we will understand how this works. So it basically adds a more layer to our first normal form, second normal form, as well as the third normal form. So a Boy's Codd normal form is also known as a 3.5 NF, which is a superior or advanced version of 3NF and was developed by Raymond F. Boyce as discussed, which could tackle certain types of anomalies which were not resolved with the help of the third normal form. So the first condition of the table to be in Boy's Codd normal form is that the table should be in the third normal form, and secondly, every right hand side attribute of the functional dependency should depend on the super key of that particular table. So for example, for any dependency, let's say a relation X to Y, X must be a candidate key or a super key. In other words, for dependency X relates to Y if Y is any prime attribute. So X cannot be a non-prime attribute. So now in general, if a table is in third normal form, it would possibly be in BCNF, and similarly like 4NF and 5NF as well. So we do not need much of BCNF. If we know what is exactly 1NF, 2NF and 3NF, we are good to go, and which is more than sufficient for a beginner level. So that was all about the BCNF, guys. And that brings us to the end of today's session. And let us now finally understand some of the benefits of normalization by understanding some advantages of normalization. Now, the first obvious reason is it reduces redundant data. Now, we might have a multiple data or multiple values in our database without because of human errors, or we do not know what we are entering. So we might add additional files without our knowledge. So in order to reduce that, repeated values or unnecessary records, we need normalization. Normalization also provides data consistency within the database, and it is also more flexible, and it gives more flexible data design, which in turn gives a higher database security, and it is also better and quicker in execution as well. So that was some main advantages of normalization. And talking about disadvantages, there aren't much disadvantages to talk about. Like, since the data is not duplicated, we need table joins in more numbers, which would make queries more complicated, and thus read times are also slower. Since joins are required, the indexing of the tables also does not work as efficiently. Again, this makes read times slower because the joins don't typically work well with the indexing. We are going to learn about SQL regex. Let us first understand what is SQL regex. Now, SQL regex is defined as regular expression which contains a sequence of characters that are used to search and find a particular sequence of characters that matches a pattern. It is a rule that defines the way characters should appear on an expression. Search pattern is determined by the sequence of character or set text. Say, for example, if you want to identify the data that contains a combination like a student's name, a contact number, email ID, we can use a regular expression. It is also used in cases where you need to identify a particular text pattern, or you need to apply a filter over numbers, text, or special characters data. Now, you might be wondering, we have SQL like operation, so how is it different from the like operation? So basically, guys, if you're working on complex data set, and if your search pattern is quite difficult, in that case you have to use the SQL regex. So basically, regular expression provide a powerful means of identifying a pattern within a body of text. So a pattern describes what the text to identify looks like, and it could be something quite simple, such as that which describes any, like, let's say, a 3-letter word or a 4-letter word, to something quite complex like that which can describe as an email address. So it is a tool that gives you a concise and flexible way to identify strings of text for a text example like characters, words, based on patterns and etc. So let us now understand why we use SQL regex. Now, regular expressions provide a powerful and flexible pattern matching that can help us implement power search utilities for our database systems, and it is also not case sensitive. That is, it can work on both uppercase and the lowercase as well. So if you want a particular case, you can mention them and you can proceed with your database set. So basically, it provides a simple yet powerful mechanism for rapidly describing patterns, and greatly simplifies the way in which you search, extract, format, and manipulate the data in your database. The second reason is it queries database to find a smaller subset of data within a table. Now, as we all know that a simple form of pattern matching has been a part of SQL through the likes of the SQL like operator condition that provides two variants of wildcards with the 0 or more than one characters, that is the percentage and the underscore. So such characters are termed as meta characters, as they describe the pattern rather than the partake in it. So a simple example could be like, if you want to find a name that starts with ABC, in that case we use ABC percentage that matches any row that begins with the characters ABC, right? So in many cases, like is limiting, and other solutions have been sought as mean to perform more complex queries. So that is the reason we started using SQL regex. And finally, as discussed, it supports various meta characters for more flexibility. Now, unlike SQL which provides only two wild characters, that is percentage and underscore, we have a lot of meta characters when we use regular expressions, which we'll be discussing in a while. So those were some of the reasons why we need to use SQL regex. And
Finally, we'll discuss how it is different from SQL like operation as well when we jump into MySQL for execution part. So let us now understand the syntax of regex, that is a regular expression. The syntax is followed as select column list from table name where string column regular expression pattern. So basically the statement performs a pattern match of a string column against a pattern. So if a value in the string column matches the pattern, the expression in the where clause returns true, otherwise it returns false. So if either a string column or the pattern is null, the resultant set is also null. So again, we have the select statement, which is the standard SQL keyword to retrieve the data, and we have the column list, which basically specify the rows that are to be retrieved, and we have where clause, which is used to specify a condition while fetching the data, and then we have the field names, which represents the name of the column on which the regular expression needs to be applied on, and then we also have the regex p, which is the keyword that is used to find the pattern. And finally, you have to mention the pattern, which is basically a user-defined regex pattern using certain meta characters to search the data. Alright, so let us now discuss some regular expression meta characters that are used in SQL. Now, the first one is the asterisk operator. So, the asterisk meta character basically is used to match 0 or more instances of the strings preceding it. Now, we'll understand this when we are executing in the MySQL workbench. So, I'll just explain the description of how this meta characters work. So, next we have the plus meta character, which is used to match one or more instances of a string. And next we have the question meta character, which is used to match 0 or only one instance of a string. And then we have the dot character, which is used to match any single character in exception of any new line. And then we have the caret, which is the symbol which you can see, and we have the vertical bar or the pipe symbol, which is used to start the matching at beginning and which is used to find the characters alternatively respectively. Next, we have the square brackets and the closed brackets, which are used to match any of the characters in the enclosed characters, which basically matches all the characters that are mentioned within the brackets. And if you want to find exact exact name or the character's name, you have to take the closed brackets. And then we have the closed brackets, and we have the caret meta character, which is used to match only those characters excluding the ones that are enclosed within the square brackets. And finally, next we have the uppercase and lowercase characters as well. If you want to specify only, if you want to retrieve only certain data which is in, like, if you want in uppercase letters, you can use from A to Z, which in upper cases, and similarly in lower cases, that is from A to Z. And finally, you can also perform operations on the numerical values as well. So within these square brackets, you can mention any numbers starting from ranging from 0 to 9, which basically matches any digits from 0 through 9. So these are the most commonly used regular expression meta characters. So let us now discuss some SQL regex operation and see how they exactly work. So you can also take a snapshot of this so that it can be handy in future as well. So for example, if I have an expression where I'm stating as ABC, that means the query is basically searching the exact character sequence, that is ABC, that it should be in a proper sequence, but it can be in anywhere, that can be in any position of this string. And next we have the caret ABC, that is ABC should start at the beginning of this string. And similarly, we have ABC $, which will basically search for ABC pattern at the end of this string. And we have A pipe B, which will retrieve the values which has either a character A or B. Now we can also perform multiple operations using various meta characters simultaneously. Now if you look at here, I have taken the caret, I have taken the pipe symbol as well as the $ symbol. So which basically states that it will look for the string ABC at the beginning or at the end of the string. So and so on, you can look at different operations, which we'll now discuss as we jump into the MySQL workbench for execution part. So let us just jump into MySQL workbench. So as you can see, MySQL workbench has started. Let us now consider a simple table to perform MySQL regular operation. So let us just consider the Netflix table, which is in our database. So
Let me just retrieve the values. I'm using select star from Netflix. So the Netflix table has various attributes here, guys, which has show ID, type, title, director, country, date, which is added, release year, rating, duration, and genre. So let us perform some basic to advanced, SQL regular queries. So let us start with a simple one which matches literally the complete sequence of a string that we've discussed earlier. So let's say if I want to find the title from the Netflix table where the title starts with, let's say, let us take any sequence like ran, okay? In that case, the following query would be select title from Netflix where title regexp is the keyword, and within a single quotes mention the characters that you want to see. So let us take ran, as I've said earlier. Let us just execute this query and we'll see the output. So it will basically search for all those titles which has RAN, that is ran in the same order or the same sequence. So if you look at here paranoia, which has a RAN in the same or the in the same order. And similarly we have transformers again, which it has RAN. And if you look at the next title, which is how to become a tyrant, similarly in tyrant we have RAN, and so on. So in this case you can take the multiple characters to find a complete sequence that is in its original sequence. Alright, moving ahead, not just only characters, guys, you can also find for a particular word, which is basically a substring. So let's say if I want to find, let us consider love. So if you want love in our title, let us just mention love in the single brackets and we'll see the output. So as you can see, there are a total of 3 titles that has a love substring in the complete title. For example, Sam Smith, Love Goes, Live at Abbey Road Studios, and next we have Love Don't Cost a Thing, and finally Love in a Puff. Alright, moving ahead, let us now discuss another example where we'll use the asterisk, the plus sign, and the question mark. So let's say if I want to find the title from the Netflix table again, where in the pattern is it starts with A and N, and it should at least have a one instance that it occurs, and finally it should have an K. So what, I know it's a bit confusing, so let me just write the query so that you guys will understand. So select title from Netflix where title regexp an star operator and mention K. So what this query does is it will find all the titles from the Netflix table which has A, which has N. That is, now as we discussed, the asterisk operator finds characters which have 0 or more instances that occurs in a table, right? So in that case the asterisk operators work. So let us now execute and we'll see the output. So as you can see, these are all the titles that has A and K as the sequence, wherein it can have 0 or more than 1 N. So if you look at Sankofa, it has A and K, which has 1 N. And similarly, if you look at the Bangkok breaking, it does not have N in between. That is because it can have 0 or more than 1 N. So in that case, we are taking the Bangkok breaking as well in our title, and similarly the others as well. So in this way, if you want to use this asterisk operator wherein the first one has a character and then the next one has 0 or more than 1 instance of appearing in the sequences that you have mentioned, in that case you'll use the asterisk operator. So let us now take another example where we'll understand how to use the pipe meta character. Let's say if you want to find the genre of all the details of the titles, where it can be crime or it can be either thriller or it can be fantasy. So in that case, the following query would be select star from Netflix where genre regexp within single quotes. Now I want the genre to be either crime, and I'll mention the pipe symbol. So do not mention the space here, guys. directly mention it. And why it can be thriller, and finally it can be a fantasy as well. So let us just execute this statement and we'll see the output. So as you can see, if I scroll this a bit, so it will display the records of all the titles that were added to Netflix, which has genre of either crime, thriller, or fantasy. So if you look at this, for example, title Ganglands, which is crime TV shows. Similarly, second one we have Crime Again, and if you look at, we have a thriller here, which is basically movie Paranoia, and similarly we have fantasy as well. I guess if you scroll down a bit, we can find it. So as you can see, we have action, adventure, sci-fi, and fantasy. So it will basically search for all the substrings which has a crime, a thriller, a fantasy substring in the genre names. So this is how you can use the pipe operator instead of, now when we, if you remember, if we use the SQL like operator, which we use the percentage sign, right? So in that we have to use multiple or operator in order to find the result. So in this case, we are just mentioning the pipe operator, which will automatically search for all the characters or the strings that you have mentioned. Alright, let us now move to another example wherein discuss another scenario wherein we'll match multiple characters with a single characters. So what I mean from that is, let's say if I want to find the details of all the titles which has a combination of characters B, C, and R. So in that case, the following query would be select star from Netflix where title regex P. Now within the close brackets, I'll mention two words, that is BC. Let us take as a BC, and I'll close the brackets and I'll mention R next. So it will basically search for all the patterns which has either BR or CR in the title name. So let us just execute this and we'll see the output. Okay, let us just only mention the title so that we have a clear idea. Alright, so as you can see, if you look at the pattern BR, right? So in the first one we have the Great British, which has BR continuously. So it does not mean that it can have at any random position. It should be in a sequential order, that is continuous position. So BR we have British, right? Next, if you look at the Bridgerton, again we have BR, and similarly if you look at the Cobra Kai, we have BR again. So that was one instance. Now if you look at the CR combination, right? If we compare to the CR combination, we have crime stories which has CR. And similarly, if you scroll down a bit as well, you can find some more examples of CR as well. So again, you can find Crocodile Dundee in Los Angeles, which again starts with CR pattern. So in this way, you can find multiple characters while mentioning them in the square brackets and with a single character as well. Alright, let us now move to another example where we'll use the close brackets. Now the close brackets is complete opposite of the square brackets, which will find the exact word that you are trying to find. So let's say if I want to retrieve the director details of the shows that they have directed, and the director's name should be either, let's say, Anthony, or it should he can either have his name has that can start with B or a character C. So in that case, what I'll do is select director from Netflix where director regexp mention the single quotes, and we'll use this operator, which is basically the caret symbol, and within the close brackets I'm mentioning Anthony, that is the director names should start with Anthony, or his name can start with B, or his name can start with C. So this is one of the pattern that we are looking into now. So let us see how it executes. So let me just display the results. Alright, also we will use the order by so that we'll have in the descending or ascending order as per our wish. So, alright, as you can see in the resultant set, the director's name has started with B, so which is satisfying a condition which you have taken B. And similar, if you scroll down, we have the director's name starting with C, which is again satisfying the condition that we have taken. And also it will look for the director name whether it is starting with Anthony or not. So I don't think we have Anthony here in this. So it will omit. So you can basically take any other character as well. So let's say if I want the director names to start with M, so in that case it will search for it as well. So if you scroll down, it will display the records of all the directors who has M as the starting letter. So we have like Mark Romson, Mark Thornton, and Martin Campbell, and similarly, etc. So in this way, you can use the close brackets with the caret symbol as well as the pipe symbol to find another pattern in this way as well. So now if you want to find the director's name other than M, B or C, in that case you have to use the negation operator, which is basically another caret which should be embedded inside the close brackets. So when you execute this query, alright, so we have to use the square brackets here in order to retrieve all the details of director's name whose name doesn't start with the characters M, B or C. So if you look at the resultant set, it is displaying the directors names like starting with A, D, F, G, H, J and so on, S, T, W and Y. That is basically except M, B and C characters, it will display the records of all the directors. So in this way, you can also use this kind of pattern in order to find the data as well. So let us look into our final example wherein we'll perform a complex regular expression search, wherein we'll find the title, the directors and the release year and the type, that is the genre, from the table where the title name will be within a range. So let us consider a range here, that is the all these the title where the title name starts with a character C and it can be in between C to K, and it should have a type from Netflix where title regex P is a keyword. Open the single brackets. I'll mention the caret symbol and let us mention the range now. So I want the title's name in the range of the characters C to K. So let us mention them and we'll close the brackets and then mention the dot symbol because it will allow you to find a single character in between, and we'll have a total of 12 characters. So the title name should be of total 12 characters and we have to mention the dollar symbol. So let us just execute this statement and we'll see the output. So if you look at the resultant set in the we have the title names which has a total of 12 letters. So if you count the first title, which is final account, 1 2 3 4 5 6 7 8 9 10 11 12, so it has exactly 12 characters in it, and it is also satisfying the condition within the range, that is it is starting with the character F which is lying in the range of C to K, and similarly all the others as well. So in this way you can also mention the range in the pattern that you want to search for as well, and you can also use the numerical values. Now we don't have as such of numerical values to retrieve, so I'm not taking any examples. So I hope you understood this various scenario, guys. So that brings us to the end of today's session. That was all about the SQL regex operator. Now, as we know that the advantage of using a regular expression is that you're not limited to search for a string based on a fixed pattern with the percentage sign or an underscore, which is the wildcard characters in the like operator. So the regular expression have more meta characters to construct flexible as well as the complex patterns. So that is the reason why we are using the SQL regex operation. And coming to the disadvantages of using regular expression is that it is quite difficult to understand and maintain a complicated pattern. So if you're an SQL beginner, you might struggle with all these patterns. So with a question given, you have to change the patterns accordingly. So if you're working on first time with this regular expression, so you might find it a bit difficult. So therefore, you should describe the meaning of the regular expression in the comment of the SQL statement so that you can understand clearly. In addition, the speed of the data retrieval in some cases is also decreased if use complex pattern in regular expression. We'll be going through top 5 tricky SQL questions. Alright, as you all know, learning how to answer the SQL interview questions is a powerful skill which can make the difference between getting hired for the job or not. And nowadays, the competition for one job is quite high and many candidates are applying for the same position. So if you want to get hired, you cannot afford for not being prepared to present yourself as the best fit candidate for that particular job role. So in order to answer the interview questions, one of the main area where you can prepare the best is especially when it comes to the most common SQL interview questions, because these questions are asked during all the job interview questions, right? So in this session, we'll be discussing some SQL queries where you can practice them and which will also help you during your interviews as well. So let us jump into MySQL Workbench in order to execute this top 5 tricky SQL queries. So let's get started. Alright, as you can see, MySQL Workbench has started. So firstly, let us look at some of the key things that you need to keep in mind while, preparing or answering the interview questions. Now, the general questions will revolve around key concepts like, asking the different types of commands in SQL, different constraints, indexes, views, joins, different functions, and etc. And at the same time, not just this theoretical and the scenario based questions rather than the objective questions wherein you can be asked to write a query, a proper SQL query wherein the interviewer wants to test your knowledge in deep, whether you're understanding the SQL queries or not. Now, this level of interview questions also entirely depend on the position that you are applying. So keeping in mind, I have already created 5 SQL questions that you might find tricky. So this might be useful for a beginner as well, which is the difficulty of the queries is from beginner level to moderate level. So you can easily answer these queries, but there is a bit of a tricky part in them as well, which we'll discuss as the session progresses. So before answering the queries, you have to be thorough with all the concepts of SQL. So we have a dedicated playlist on SQL wherein we have covered various topics on topics and concepts regarding SQL. So make sure you check that out before you start performing the queries. So let us discuss the queries one by one. So the first query is write an SQL query to fetch the third last record from employees table. So let me just open this new tab. Alright, let us now first display the records from the employee table, that is select star from employees. So as you can see, the employee table has various columns such as, employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and department ID. So the query that was asked is write an SQL query to fetch the third last record from this employee table. So if you scroll down a bit, and you can see the last record is William, and the third last record is Herman Bayer. So basically, we need to get the record of this employee who's having employee ID as 204, whose name is Herman Bayer, and he works as a PR, as a specialist on PR. So right. So basically, you can solve this, in different ways. So basically, the logical approach is using any window function, which we'll be discussing now, and sort the data in descending order, based on the employee ID, and then provide a row number to each of the record and fetch the record having row number as 3. I know it is a bit of confusing, so let us just directly write the query first so you guys can have a clear-cut understanding. Select, mention all the rows you want in your resultant table. So I am taking employee ID, their first name, their last name, department ID as well, salary, from. Now we have to write a subquery in this, wherein we'll use select operator, select star, comma. Now we have to use a window function here. Now the window function which I'm going to use here is row number function. So the row number function is basically SQL ranking function that assigns a sequential ranking number to each new record in a partition. Now when the SQL row number function detects two identical values in the same position, it will assign different rank numbers to both. So the logic behind is that we'll be assigning row number to each of the records based on the employee ID, and then we'll find the third last record from this table. All right. So row number, and I'll be using the over, which is the syntax, and we'll sort the data in descending order. So order by employee ID in descending order from the employee table, that is employees, where you have to mention the row number as well. So row number, so let us take the row number here as row number. This is basically a subtable, right? So you need to mention the row number as well, where row number is equals to 3, since we are finding the third last record from a table. So let us execute this and we'll see the output. So there is an error which says every derived table must have its own alias. So I think we forgot to mention the alias name for the table here. So let us take the alias name as employees E here, and let us take it as X. So it will basically be x.rn. So I think it is correct now. So as you can see, in our resultant set, we have got the resultant table, which is of Herman's Bayer record whose employee ID is 204, just as we discussed previously, which is the third last record in the table, who belongs to department ID 70 and his salary is $10,000. So in this way, you can simply use the window function row number to find the third last record from the table. So similarly, you might be asked to find the second last or fifth last in different contexts. So the scenario might be different, but the order and the approach to solve this query is the same. All right, moving ahead, let us now discuss the second query. Now, the second query states that from the Olympics table, fetch the details of all athletes who belong to the same country but have participated in different Olympic games. All right, so let me just open another tab. So firstly, let us retrieve the details from the Olympics table, which is select star from Olympics. So the Olympic table has various attributes like ID, name, sex, age, height, weight, country, NOC, games, year, season, city, sports, and event. So what the query states is, from the Olympics table, fetch the details of all the athletes. So we are concerned with this column, which is name, which is the details of all the athletes who belong to the same country but have participated in different Olympic games. Now in the resultant set, we need to have the resultant table which has the details of all the athletes who are from the same country but have participated in different Olympic games here, like the 1992 summer, 2012 summer. So basically they have to be from the same country but different games. Now the logical approach to write this query is basically by using the self join to solve this problem, which is used to join a table to itself to compare the values within the same table. All right, so let us discuss the query now. So again, in order to solve this query, you have to be thoroughly, knowing the joins concept. So We also have a dedicated video on that as well, where you've discussed the various different kinds of joins. So make sure you check that out as well. So let me just write the query select. Now there might be multiple athletes participating in same or different games, right? So I'll be using distinct clause here, distinct. And since we are joining the two tables, we need to have a temporary name for two different tables. So for the first table, I'm taking it as d1 dot name, which is the athletes details. Next, I'm taking d1 dot country, comma d1 dot games from Olympics, which is the first table d1. And then I'll use the join keyword, which will basically self-join the same table, which is Olympics again, but we have to mention a different temporary name, which will be D2 here. I hope you're understanding this. On D1.country equals to D2.country. So the condition that I'm specifying here is that we need to have the same country here. That is, the athletes participating in different Olympic games should be from the same country, but he should have played different Olympic games. So in that sense, I'm using another condition, which is AND operator, where D1 games, I'm using not equals to operator here, which will compare two operators if they are same or not. If they are not same, it will retrieve all the values. So D2 dot games. And I'll similarly use an order by, so we can have in sorted order, which is order by name, as well as, let's say, country as well. Alright, so let us now execute this statement and we'll see the output. Alright, we have the resultant set. As you can see, in a resultant set, we have the details of athletes who have participated in various different games but belong to the same country. Now, if you look at A. Dijang, who's belong to China, has participated in 1992 Summer Games, whereas A. Lamusi, who is from the same country again, China, but has participated in 2012 Summer Games. Now, similarly, we have this Abdul Latif. Oh, it's a big name. Let us just take another one. We have Agostino Abangel, who's from the country Italy, who has participated in 1988 Summer Games. Similarly, we have, Alejandro Abascal Garza, who's from Spain, who has participated in various different games ranging from 1984, 1980 and 1976 Summer Games. So in this way, you can find the details of all the athletes who's from the same country but have participated in different games. Alright, let us now move on to the next query, which is write a SQL query to display only the details of employees who either earn the highest salary or the lowest salary in each department from the employee table. Alright, so let me just open another tab and we'll retrieve the details from employee table again. So start from employees. Alright, we have the employees table. So the question, let us go through the question again, which says write an SQL query to display only the details of employees who either earn the highest salary or the lowest salary in each department from the employee table. So we need to provide in the resultant set the details of all those employees who are either having the highest salary or the lowest salary from each department. Now the logical approach to this question can be is like we can write a subquery which will partition the data based on each department ID and then identify the record with the maximum and the minimum salary for each of the partition department. And you can finally, from the main query, you can fetch only the data which matches the maximum and the minimum salary returned from the subquery. I know it is a bit confusing, so let us write the query so that we'll have a clear understanding again. So select, I'll just display all the records. So I'll use the select star operator. Select star from employees. So we'll give an alias name since it will take a lot of time writing employees each and every time. So I'm just taking it as E. Now we have to basically self-join where it will compare the records from the same table. So I'm using the join statement again, and I'm using a subquery, and within the subquery I'm basically selecting the records again, which is select star. And now we have to create the partition for maximum salary and minimum salary in our employee table. So create a partition which is maximum salary over partition by department ID. Now, since we want the highest and lowest salary from each department, so I'm considering the department ID here. Now, since we are using the partition, we need to give a name for this. So we'll take it as max salary. And similarly, you have to create, minimum salary partition as well. The syntax remains same, guys. Just mention it, partition by, again, department ID. This will be minimum salary. All right. From the table which is employees. Now, since this is a subquery and it is a derived table, we need to give a alias name for this table as well. So we'll just take it as X. And since we have used the join, we have to mention the join on which table we have performed, which is basically a self join on the employee table itself. So E dot employee ID, which is basically the primary key, which will uniquely identify all the records. So that's why I'm taking employee ID here, is equals to X dot employee ID. All right. And now mention the condition here. So the condition is basically it should match the salary with the maximum salary from the table, that is employee, or it should match the salary with the minimum salary from the same table, that is employee. So I'll be taking E dot salary is equals to X dot maximum salary. All right. Or the condition can be E dot salary equals to X dot minimum salary. So it will basically find all the details which has the salary which is either maximum or minimum, right? That is it. And you can also use order by if you want to get in a particular order. So order by X dot department ID comma X dot let's say salary as well. All right, I think we do not have any error. We can just directly run the query and we will see the output. All right, our query has been successfully executed and we have a total of 18 records. So let us just understand how the query has worked here. All right, now we have various departments IDs that are being displayed in a resultant table. Now if you look at the first department ID, which is 10, the maximum salary is 44,000 and the minimum salary is also 44,000 in this department, and the employee ID or the employee details is Jennifer Wallen. So let us just discuss another example here. So next let us move on to the department ID 20, which has the maximum salary as 60,000 and minimum salary as 30,000. Now we have a total of 2 records here, that is basically Michael Haston, who is basically having the lowest salary in the department, who belongs to the department 20, and we have Pat Fay, whose salary is the highest, which is 60,000 in the department 20, which is being displayed here in the separate section as maximum salary and minimum salary, and so on for rest of the department IDs also. It will basically segregate all the details of the employees who is having the maximum salary and the minimum salary. So I hope you've understood how to solve this query. This isn't rocket science or having a lot of difficulty to solve the question. We have just basically used a self join and a partition by statement. Now partition by is basically an optional clause used in the row number function basically, which is a clause that divides the resultant set into partitions like group of rows. Now the partition which we have created is basically the maximum salary and the minimum salary. Now when this row number is applied to each partition, which assigns a separate rank number to each partition, right? So in the same way we can see that different salaries are being assigned to the maximum salary partition that we have created. Alright, let us now move on to our next query, which is our query 4, which says write SQL query to find the 7th highest salary from a table without using the top or limit keyword. Now, this is one of the most common SQL, interview questions, is to find the nth highest salary of employees, where n could be anything like 3, 4, 7, 13, anything, based on number of records that the interviewer wants to know. Like, in order to find the, let's say, 13th highest salary in SQL, sometimes this question is also twisted to find the nth minimum or nth highest maximum salary in SQL. Now, since many programmers only know the easiest way to solve the problem is using the top or the limit keyword, which will directly fetch the records. Now, what if the interviewer wants to know another, case to solve this problem? So in that situation, what you will do, you cannot use the top or limit keyword for that. So basically, we use the row number function or the rank or dense rank function to find the nth highest salary, highest salary from the table. But in this case, we shouldn't use all those and even the top and limit keyword. So let us now see how to write this query. So let me again use a new tab. Now, in order to find the nth maximum salary from the employee table, we have to use a correlated subquery. Now, the question that is asked is to find the 7th highest salary from the employee table. So basically, a correlated subquery is a special type of subquery where the subquery depends upon the main query and executes for each and every row returned by the main query. Now, the only drawback of this is that it is a bit slow, but it can solve the problems which are difficult to solve. For example, like to find the 15th, 20th, 100th, like in 1000th, highest salary from the employee table. So let us now write the query so that we'll have a clear understanding again. So the query is followed as select. So basically, first let us find the 7th highest salary. For that, I'll be using the maximum. Select max salary from the employees table. Sorry guys, there was a mistake. We shouldn't need the maximum salary. We just need the salaries and in the order of which they are separated. So order by salary in descending order, that is from highest to lowest, we'll be sorting them, right? So let me just execute this query. So the highest salary in our table is 93,000 and the second highest salary is 90,000. So the query that was asked for is to find the 7th highest salary, that is 1, 2, 3, 4, 5, 6 and 7. So 80,000, okay, we have repeated values, so we'll just use the distinct keyword as well so that we'll have unique records. Alright, so 1, 2, 3, 4, 5, 6, 7. So the 7th highest salary is basically 79,800. So we need to now fetch the details of the employees whose salary is basically the 7th highest salary, which is 79,800. So the query would be followed something as select star from employees. Let us take it as E1, since we will be comparing the same table, where n-1. I'll explain in the at the last why we are using n-1 here, guys. So let's just continue with the query. Now we have to write a correlated subquery, just we've discussed earlier, which is basically select count distinct salary. So I'm using distinct E2 dot salary. Basically, we are comparing the same table once again from employees E2, where mention the condition on which you want to perform the separation. Now we need to find the highest salary, right? So the salary in second table, that is E2 dot salary, should be greater than E1 dot salary. So this is what the query exactly is, guys. So let us just understand how this query is working here. So as I said, the distinct keyword is there in order to deal with any duplicate records or the salaries that are present in the table. So in order to find the nth highest salary, which is basically we need to find the 7th highest salary, right? We are only considering the unique salaries here, and the highest salary means no salary should be higher than it. For example, if the second highest salary means only one salary is higher than it, that is the first salary. Similarly, the third highest means no two salaries are higher than the first two salaries. Similarly, for the 7th highest salaries, you can say there are n-1 salaries that are higher than it. So for example, if I'm taking 7th salary, so n basically becomes 7. So 7 minus 1 is basically 6, right? So which is finding the 7th highest salary from the table. So let us just execute this and we'll see the output. So as you can see, the 7th highest salary that we have already seen the output table, which should have 79,800 as a resultant table. And it is showcasing all the details of the employees who's having the 7th highest salary, who is Payam Coughlin, whose employee ID is 122, whose email is P Coughlin, his hiring date, his job ID, and the rest of the details are being displayed. So in this way, you can find the nth highest salary from the employees table. So this is basically a generic solution which works in all databases, including MySQL, Oracle database, SQL, PostgreSQL. And the only drawback, as I said earlier, is it is slow because the inner query will run for every row possessed by the outer query. So do let us know in the comment section below what all different methods we can use for this same query. And we also have a dedicated video on how to find the nth highest salary using various keywords like the top, limit, using dense rank functions. So you can check that out as well. So moving on to the final question, guys. The final question is, write an SQL query to fetch the details of all the shows and the countries and sort the shows made in India at the top and the rest of them in ascending order. I think this is from Netflix table. So from the Netflix table. So let us just retrieve the details first and we'll see how the query works. Select star from Netflix. Alright, so the Netflix table has the show ID, type, title, director, country, date added, release year, rating, duration, genre. So let us go through the query again. It says that we need to fetch the details of all the shows. That is basically the title. These are the show names, right? And the countries. We have the countries also which they are made in. And sort the shows that are made in India at the top. That is, we need to display all the shows that were made in India at the top level and the rest of them in ascending order from the Netflix table. So I hope the question is clear, guys. So let us now write the query. Alright, since we are only concerned with the the show name, that is the title, and the country, we will just select those. Now we may have the titles repeated, so I'm just taking the distinct values, distinct title, comma, country from Netflix, and we'll basically order by country first and we'll see how the output is. Alright, so it basically displays all the show details of all the shows that were made in by different countries. For example, you can see El Patron, Rodrigo de Increment has been made from Argentina. We have a level 16 from Canada. So the query that was asked is, we need to sort the shows made in India at the top and rest of all the shows in ascending order. So basically we need to have the show names that are in India. So let me just check. We have we have certain shows that were made in India as well. So you can see there are a list of so many records of all the shows. For example, Angamali Diaries, Anjam, Dhanak, Gurgaon, Jeans, Minasara, Kanavu, and so many others. So basically in a resultant set, we want all the details of all these to be at the top and the rest of them in the ascending order. Like for example, Australia, and then we need Brazil, and then Canada, and similarly France. So basically in the alphabetical order. So the logical approach for this is using the case expression, guys. Now that is the tricky part where the interviewer wants to know whether you're familiar with this concept of case expressions. So basically the case expression goes through the conditions and return a value when the first condition is met. Just like an if and else statement you use for other programming languages like C, C++. So once the condition is true, it will stop reading and return the result. And if no conditions are true, it returns the values in the else clause. So basically we need to mention the case condition here. Alright. So the query is followed as, so mention the case keyword. The syntax is followed in this way, which is case when country is equals to India, then return 0. That is basically return the true values if there is any record or the title name having India, else we'll mention it as 1. And finally we'll end the statement, which is again the keyword we have to use for case expression. Alright, so let us now just implement this and we'll see the output. So there was a minor error, guys. So as you can see in a resultant set, we have the details of all the shows that were made in India that is being displayed at the top. As you can see, we have all the list of all the shows of India. And then after that, the query states that we need to sort the rest of the remaining shows that were made from different countries in ascending order. As you can see, just like we have discussed earlier, the country names have been sorted in ascending order, like Argentina, Austria, Brazil, Canada, China, Italy, Japan, Nigeria, and so on, Pakistan, United States, right? So United States is the last country which is being sorted in the alphabetical order. Now the same question can be asked, when we have multiple conditions to specify. Now for example, if I want all the shows that were made in India as well as Germany to be at the top and the rest of the remaining shows from different countries to be sorted in the ascending order after the shows that were made in India and Germany. So in that case, the query just remains the same. You just need to add another condition. Now first, which is case and country is equals to India, then 0. Next, the condition will be case. I don't think we need to write the case again and again. When country equals to Germany, then we'll specify it as 1. So if there is no country that is having shows other than India and Germany, so we'll mention it as 2, and we are ending the statement. So let us just execute this query and we'll see the output. So as you can see in a resultant query, firstly we have the case condition which will retrieve all the details of the shows that were made in India, as you can see in a resultant set. And after that we need to have the shows that were made in Germany. So since we have mentioned the country as Germany, it is being displayed as Germany. That is the titles or the shows that were made in Germany, and the rest of the remaining shows that belongs to other countries, and we need to sort them in ascending order in the form of their alphabetical orders, like Argentina, Australia, Brazil, and so on. So this query is asked in general, when you want to give certain records a priority. That is, you want to mention, you want to display certain records at the top and the remaining at the bottom. So in that case, this query will be useful, which can be done using a case expression. We'll be discussing about common table expressions in SQL. Now, as you all know, working on long queries with complex logic is common for any SQL developer out there. So this can include using various joins, various levels of aggregation, data aggregations, and filtering across any number of tables. Now, in some cases, a resultant set cannot be obtained with a single query using a select statement or using a where condition. It requires a series of queries to be put together. Now, furthermore, for complex queries, the best way to write a query is to break it down into a logical steps and build it piece by piece. Now, subqueries are typically one way to consolidate functionality into a single SQL statement that can be later be incorporated back to the main query. Now this has the potential to be useful, but it is also challenging for a beginner who has just started with a new level to read and comprehend and understand it well. So this is where, and it is possible to simplify difficult queries into a sequence of logical steps using CTE or common table expressions, which also helps to make your queries more readable and allow you to produce more complex resultant set. So in this session, we'll be discussing all about common table expressions or CTEs in SQL, how they are used, and implement them using certain examples in MySQL Workbench. So without any further ado, let's get started. So firstly, let us understand what is SQL CTE. Now CTE stands for Common Table Expressions, and in SQL it is a temporary resultant set that has a range within a single SQL statement. Now a CTE can be referenced at any place within that statement multiple times. Now generally the with clause is used to define a CTE. A common table expression do not exist as a separate statement. Instead, it is always used along with a select, insert, update or delete statement which immediately follows the CTE. So it is generally used and it enables users to write and maintain complex queries easily with increased readability and usability. So you can basically define multiple expressions within a single query. So once defined, these expressions can be referenced repeatedly throughout the rest of your queries. Now, common table expressions was relatively a new SQL feature which was lately introduced in 1999 by Microsoft SQL Server. Now, CT was first introduced in SQL Server in the year 2005, and then PostgreSQL made them available starting in 2009, and which was further used by MySQL, which has waited a bit longer and made them available in the year 2018, starting with the version of 8.0. So again, simply put it together, it is a temporary data set, guys, which returns, a query which is then used by another query. So in order to reduce the complexity of a query, we use CTE. So it is temporary because the result is not stored anywhere. So it exists only when the query is being run. So that is what CTE is all about. So let us now move ahead and let us understand why we use SQL CTE. Now the main reason is to store the result of a complex subquery for further use. Now in SQL, we will use subqueries to join the records or filter the records from a subquery, right? So whenever we refer the same data or join the same set of records using a subquery, the code maintainability will be difficult. So a CTE makes improved readability and maintenance easier for the user. And another reason being is CTE can be reusable, guys. Now, the reason why I'm telling it is reusable means, a CTE is reusable by design. Instead of having to declare the same subquery in every place you need to use it, you can simply use a CTE to define a temporary table once, then refer to it whenever you need it. So you can call upon the specified CTE whenever you want in your query. Also, CTE is more readable than a subquery. Now, another reason why we use CTE is they are more readable than subqueries. Since CTE can be reusable, you can write less code using CTE than using subquery. Also, people tend to follow the logic that we put behind the CTE in an easier way than in a nested query fashion. So whenever you write a query, it is easier to break down a complex query into smaller pieces using CTE. And finally, CTE increases the performance of a query. Now, if you're working on a complex data, performance is paramount, right? So using subqueries, using multiple joins and joining various tables put together can, decrease the performance of a query. Now, CTE can be defined in various scenarios like in procedures, views, triggers, and many more. So it can be used recursively with a subquery not, which can ultimately increase the performance of a query. Alright, let us now understand how CTE works. Now a CTE must be followed by a single select, insert, update or a delete statement that references some or all the CTE columns. So let us now understand the syntax of common table expression. The syntax is followed as with is the keyword we use, CTE name. Now you can specify the name of your choice for the CTE as, and within the parenthesis mention the select statement with all the columns you want to get in your resultant table and from the table name, and close the parenthesis, and after that we'll be basically again selecting the columns from the CTE name instead of the table, and you can also specify the where condition as per your requirement. I hope you understood the syntax and how CTE works. Now it will be clear when we get into the execution part. So let us directly jump into MySQL Workbench for execution. Alright, as you can see, MySQL Workbench has started, and let us now run some queries using CTE. So let us just take an example for that. Let us consider the employee table for understanding how CTE works. So let me just display the values from the employees table. Alright, so the employees table has various attributes such as employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and their department ID. So let us now run a first query wherein we'll find the highest salary of an employee working in different departments, or you can say in each department. So in that case, we'll use a CTE here. And as we discussed earlier in the syntax, it starts with the with keyword, and after that you can give the CTE name as per your choice. So let us give it as highest salary, since we're finding the highest salary of employees in different departments. So highest salary, and after that use the as keyword, and within the parenthesis use the select statement and display all the records that you want to fetch in a resultant table. So select, I want my first name of the employee, last name, comma, department ID, comma, salary. Now since we are finding the highest salary of each employee from different departments, we'll be using the rank over function. Now we have discussed about the rank over function in our previous video, which is how to find the nth highest salary. So if you want to know it in a more detailed way, make sure you check that out. So I'm using rank over, and which is followed by the partition keyword, which is partition by. We are partitioning based on the department ID here. Order by salary. And we'll use the descending keyword here because we are only concerned with the highest salary. So it will be basically from highest to the lowest point. So close the parenthesis, and you need to give a temporary name for the rank over function. So let us just let's say give it as salary rank from employees table, right? Alright, and after that we have to mention the select statement again, where we'll display all the columns that we have mentioned in our CTE again. So let me just mention the first name, last name, salary, department ID, from. Now we have to mention the CTE that we have chosen here. Now highest salary is basically the name of our CTE. So I'll mention the highest salary here instead of the table name, where salary rank is equals to 1. Now why I am choosing 1 is it will segregate all the salaries and it will only choose the highest salary from that. So alright, I think we are good to go. So let us just execute the statement and we'll see the output. Alright, as you can see in a resultant set, it is displaying all the data of the employees, that is their first name, last name, and their highest salary, that is the employees working in different department and their highest salaries. So let me just explain how the query is working here. Now the CTE is named here as highest salary. We use it to rank employees within each department by salary by using the window function rank over. Now we partition the data by the column, which is department ID. This means we rank the salaries only within each department, not across all the table, right? So the data is sorted according to the column salaries in descending order because we want the highest salary, as I said earlier, in the department to have the highest rank, which is 1. Also, we also have selected several columns from the table employees in the same CT, and we need data from this CT in the next select statement in order to fetch in our resultant set. And in the select statement, we are basically selecting the columns needed to have in a resultant set, that is the first name, last name, salary, and department ID. So in this way, you can use the CTE to find the highest salary of each employee from different departments. Now, I know you might be wondered, why CT is being used, where you can simply write a subquery to find the highest salary. Now, I get it. I'll explain it in a bit, where we'll discuss in the end why we are using CT here. So let us just again take another example here, guys, so that we can have a clear-cut idea on more how the CT can work. So in the second query, we'll be basically finding the average salary of each employee working in different employee. Now previously we have found the highest salary of the employee. In this case, we'll be using the finding the average salary by each department of the employee. So let us just write the query here first. So again, I'm taking with. So let us name our CT name as average salary here, since we are finding the average salary. And within the parenthesis, mention all the column names and the operation that you are performing. So since we are performing the average operation on the salary, I'm taking as average salary, as I am taking it as average salary. Just give it a alias name. And then we are mentioning the department ID from the table, that is employees, and we'll be basically grouping all the details of the employees by their department ID, so that we can have the average salary in each department. So close the parenthesis. Now again, we have to mention the select statement, which is the outer statement after the CT. Now select first name, last name, department ID, salary from employees table, right? Now basically the criteria which is to find the average salary is basically we have to join the two tables, which is basically the same table, that is employees, and we'll be comparing the salary of employees from these two tables simultaneously, right? So we have to join these two tables, that is the CT table and the employees table here. So that is the reason I'll be joining the table now. So let me just take the employees table alias name as E, so that we can find it easily. So E dot first name, I'm taking E dot last name, E dot department ID, and E dot salary from employees E. And basically I'll be joining this with the CT, that is average salary that we have taken. Alright, so I hope you have understood this till now. So let us just give a name to this, let's say AVG, and we are joining the table based on the department ID from both these referenced tables, right? So I am taking E dot department ID is equals to AVG, which is the name of our CT table, that is the temporary table which we have taken. So department ID, and we'll use the order by statement, so that we'll have a more clear resultant set. Order by department ID, and we are good to go now. So let us just execute this statement and we'll see the output. Alright, as you can see in a resultant table, it is displaying all the average salaries of the employees. So let us just quickly go through the explanation. So this query is using a CT named average salary, guys, in order to calculate the average salary in each department. Now the select statement in the CT groups the rows by department and uses the average aggregate function to calculate the average for each department. Now, once we have that, we combine it with other columns from the table employees to complete the resultant answer. Now, to do so, we are basically joining the employees with the CT name as we would do with any two tables to join them. So we select the columns, the required columns as we have taken here, which is the first name, last name, department and salary from the employee table, and the column average salary from the CT. So in this way, you can use the CT to find the average salary in each department of different employees. So there's a little error, guys. I forgot to mention the average salary column. So I was just wondering why we didn't have the average salary in our resultant set. So let us just mention that. Now, average dot average salary, which we have taken earlier. All right. So let us execute the statement. All right, now you can see the salary of the employees working in different departments and also the average salary of that particular department. Now, if you look at the department 10, now the salary is 44,000 and the average salary is also 44,000. Now, if you look at the department ID, which is 20, now we have two different employees, Pat Frey and Michael Haston, whose salaries are different, that is 60,000 and 13,000. But the average salary in that department is 36,500, and similarly you can see for the rest of the different departments as well. So I hope this is clear. Now it brings us to the main question, that why are we using and when we are using CT. Now, traditionally, you've probably noticed that CTs are a lot like subqueries. Maybe you're wondering why I'm using CTs when everything I did could have been done with a simple subquery. Now, that's true. Aside from being more readable, CTs have one big advantage of subqueries. That is, the resultant set or the results from a CT can be used more than once in a query. So, let's say if you're working on a complex database where you have to join multiple tables from the database, and you have to perform various operations. So in that case, you have to keep on writing the subqueries. Now, let's say if I want to find the maximum of average salary from the employees table. So in that case, now that I've created a CT, I can directly write a select statement which says select max. And inside that, I'll be writing the average salary, which is the name of the CT from the CT name that is we have taken as avg underscore salary. So now instead of calculating the average salary of each employee from different department using subqueries, which is a complete process, right? It takes a bit of time. So instead of that, I'm writing a simple CT for that, and later I'm using the same to calculate the maximum average salary. So when I execute this, it will directly display the maximum of average salary of all the employees in different departments. So it becomes quite easier, instead of writing subqueries each and every time. Now, if the code with a subquery is less readable and it is harder to understand the code with a CT in simple way, right? So you would be trying really hard just to understand what every part of the code does when you're writing subqueries. Now, having difficulties understanding the code can be frustrating. So that is where CTs can help you guys. It is one of the most powerful tools to process hierarchical complex data into a simple manner where you can use it multiple times. Let us understand what exactly is PL/SQL, and we'll understand how it is different from SQL as well. So firstly, let us discuss the agenda for today's session, guys. We'll be starting this tutorial by understanding what is PL/SQL, and then we'll discuss why we use PL/SQL, and next we'll go through some features of PL/SQL, and then we'll understand how exactly PL/SQL works and understand its structure and syntax, and then we'll understand advantages of PL/SQL over traditional SQL language. After that, we'll be going through various differences between SQL and PL/SQL. And finally, we'll wrap up the session by understanding when to use PL/SQL over SQL. So without any further ado, let's get started and dive into today's topic. So what is PL/SQL? PL/SQL is a procedural language that enables programmers to combine the power of SQL with procedural statements. PL/SQL, as it stands as procedural language extension to SQL. In PL/SQL, all the statements are executed at once, which consists of stored procedures, triggers, functions, and etc. That enhances the functionality of an operation and decreases the traffic in the database. It was initially developed by Oracle Corporation in the 1990s, and it was designed to build server pages and web applications, which exhibits features such as abstraction and error handling and many such features. PL/SQL is widely regarded as a powerful language as it extends the procedural construct to the normal SQL statements. And PL/SQL language is mostly popular because of its capability to handle major errors by introducing the procedural structure into the database. It also executes a very high speed of processing, and it can easily execute multiple statements at once in the form of blocks of codes. We'll get to it eventually. Now, let us understand why we exactly use PL/SQL. Now, the first reason is to overcome the limitations of SQL and provide the user with more features. As we all know, SQL is a query language. It is not a typical procedural programming languages like C or C++. So it does not have facilities like functions, loops, if-else, etc. So in order to have those benefits of constructs like looping, decision making, using if-else or using functions, in that case, a procedural language was created, and that was PL/SQL. Now consider if I'm performing on a database and I want to update the salaries of employees in that table. Now, if I want to update their salaries by giving them bonus, and let's say if I have like thousands of records in our database, so updating each one of the record will take time, and it is also a time-taking process, right? So instead of that, I'll just write a simple code using a for loop, which will eventually update all the records. Now, because the SQL queries are sent to the Oracle engine at the same time, the speed and the execution slows down when there is more traffic. So during data manipulation, there is no way to check for mistakes as well. PL/SQL was made to fix these limitations by keeping what was good about SQL and combining it with the procedural commands. It is made as a block structured language, and the statements in each block are sent to the Oracle engine. This makes processing faster by reducing the amount of traffic. Next, it is used to tightly integrate with SQL by providing programming constructs. Now from that, what I mean is PL/SQL is tightly integrated with SQL, and it is the most widely used database manipulation language. Now, for example, PL/SQL lets you all the SQL data manipulation, control, and transactions, statements, and all SQL functions, operators, and column operations as well. PL/SQL fully supports SQL data types where you need not convert between PL/SQL and SQL data types. For example, if your PL/SQL program retrieves a value from a column of the SQL type wildcard, it can store the same value in a PL/SQL variable of the type wildcard. You can give a PL/SQL data item that the data type of a column or row of a database table without explicitly specifying any data types. And finally, PL/SQL can write complete application programs with web interface, file processing, and real-time communications, etc., which is not possible to do with the SQL language. Alright, let us now understand some features of PL/SQL. Now, PL/SQL is an open source language which is readily available on the internet. You can just download the Oracle database and you're good to go to perform all the operations on PL/SQL. And it is a highly structured and a readable language as well. So it expresses the intent of the code clearly, and also PL/SQL is straightforward language to learn. As I said, it is a standard and portable language. PL/SQL is considered as a standard and portable language for Oracle database development. So if you develop a program that executes on an Oracle database, you can quickly move into another compatible Oracle database without any change. Now we have a wide range of frameworks when you're working on PL/SQL, like working on procedures, triggers, functions, and many object-oriented concepts as well. PL/SQL offers high speed. Now PL/SQL gives the user the performance in terms of speed and efficiency, and it is highly integrated database language. Now besides PL/SQL, you can use other programming languages such as C++, Java, and C#. However, it is easier to write efficient code in PL/SQL than other programming languages when it comes to interacting with the Oracle database. Embedded language. PLSQL is an embedded language. What I mean from that is it can only execute in an Oracle database. It was not designed to use as a standalone language like C, C++ or Java. In other words, you cannot develop a PLSQL program that runs on a system that does not have a Oracle database, which a lot of users generally confuse between SQL and PLSQL. And finally, we have the manageability. PLSQL stored subprograms increase manageability because you can maintain only one copy of a subprogram or on the database server rather than one copy on each client system. Any number of applications can use these subprograms, and you can change the subprograms without affecting the applications that invoke them. So those were some of the features, some important features of PLSQL. Alright, let us now understand the structure, the functionality and the syntax of PLSQL. Now, PLSQL is based on a block structured language. Now, PLSQL program units organize the code into blocks in general. A block without a name is known as an anonymous block. This anonymous block is the simplest unit in PLSQL. It is called anonymous block because it is not saved in the Oracle database. An anonymous block is an only one-time use and useful in certain situations such as creating a test unit. Now, this anonymous block has three basic sections that are the declaration, execution and exceptional handling. Only the execution section is mandatory and the others are optional at times. Now, the declaration section allows you to define data types, structures and variables. You often declare variables in the declaration section by giving them names, data types and initial values. The execution section is required in a block structure and it must have at least one statement. The execution section is the place where you put the execution code or the logic code. You can use the both procedural as well as SQL statements inside the execution section. And finally, we have the exceptional handling, which is optional, which is starting with the exception keyword. Now, this exception section is the place that you put the code to handle exceptions. You can either catch or handle exceptions in the exception section. So this is how it exactly looks. Now, in the declaration section, we have the keyword declare, where we define data types, structures and variables. We declare variables in this section by giving those names, data types and initial values as discussed. Next, we have the begin keyword, which is the execution section here, where the execution section is considered the most important and required section in a block structure, and it must contain at least one statement. And finally, we can also use the exception. So let us just understand this with an example here. Now, I've written a simple hello program, and the end line signals the top of the PLSQL block, that is execution starts from the top. That is, we have assigned a variable message of a data type wildcard and allotted the size, and we have put the message as hello world. Now, when the above code is executed at the SQL command prompt, it produces the following result as hello world. So this is one of the easiest and simple example of how exactly the PLSQL works. Alright, moving ahead, let us now discuss some advantages of PLSQL over SQL. So the first advantage is PLSQL supports error handling. PLSQL makes it easy to detect and handle errors. In addition to handling exceptions, PLSQL lets you check for errors and ensure that data is correct before processing it. And when an error occurs, PLSQL raises an exception. Normal execution stops and control transfers to the exception handling part of the PLSQL block. So you do not have to check every operation to ensure that it is succeeded or not. PLSQL offers high productivity and performance. So PLSQL provides high productivity performance to programmers because it can query, transform and update a data during a database. It sends an entire block of statement to the database on just one occasion, unlike SQL, which queries only a single statement at a time. So this helps to reduce network traffic and also provide high performance for the application. PLSQL offers better features like block structure programming and supports OOPS concepts. Now, PLSQL reduces the time consumption on design and debugging by strong features like exceptional handling, encapsulation, data hiding, and object-oriented data types. PLSQL is used for developing web applications and server pages. So as discussed earlier as well, it is mainly used to design web application programs or create backend logic for web pages. It is also used in integration with Java and PHP to create complex logic structures. So those were some of the main advantages of PLSQL over SQL. Alright, now that we've understood what exactly is PLSQL and why we use it and also the syntax and structure of it, let us understand how it is different from SQL. So the first difference is SQL is a declarative language which is used to manipulate databases, whereas PLSQL is a procedural language that acts as an extension to SQL for the database. The next difference is SQL is used in relational databases to execute various queries like creation, insertion, deletion, updation into the table, whereas PLSQL is used to write program blocks to perform group of operations using all the SQL statements with procedures, functions, cursors, triggers, and other packages. SQL language is capable of executing only a single operation at any given time. That means if you're performing an insert operation, or let's say if you're performing a delete operation, you just have to perform that before moving ahead with another statement for execution. Whereas PLSQL language is capable of performing various different operations at any given time. That is, at a single time, it can perform multiple operations. SQL does not support data variables, whereas PLSQL provides support for data for variables, constraints, and data types. Control structures are not supported in SQL, whereas control structures such as if-else, for loop, while loop are supported in PLSQL. Now, SQL is easy to learn and understand due to its user-friendly syntax, whereas in PLSQL, certain concepts of PLSQL can be complex and prior knowledge might be necessary for the user who has just started to working on PLSQL. So those were the main differences between SQL and PLSQL. I hope you guys have understood it. So now comes the main part, which is when to use PLSQL and SQL. Now the bottom line is that adding a new skill to your portfolio is always a good decision, as it enhances both your potential and it will upskill in your career. Now PLSQL is SQL combined with some added procedural features, and it performs all the things that SQL performs, but on large volumes of data using various packages like procedures, functions, control structures, and triggers, and etc. Whereas SQL, on the other hand, is a standard language for the database that we can use for creating, retrieving, and maintaining the relational databases. Now, SQL problems with ease, which earlier were a neck pain in the for the users, right? So in this era, data is the new oil, and managing data has been a prime importance for any user. So understanding and working on PLSQL is as important as working with SQL as well. So knowledge of SQL as well as PLSQL can prove quite handy for the beginner level or for the users who are starting at a beginner level as well. So, and another thing, guys, generally people confuse with Oracle SQL and PLSQL. Oracle SQL is not same as the PLSQL. Oracle SQL is generally the Oracle version of structured query language, that is the traditional SQL language. On the other hand, PLSQL is procedural language developed by Oracle in an extension of Oracle SQL, having the functionalities of functions and control triggers and etc.
SQL versus NoSQL by SimpliCode. Firstly, let us go through the agenda for today's session. We'll start the tutorial by understanding what is SQL, and then we'll look at why we use SQL. And after that, we'll understand what is NoSQL database, and then we'll understand why we use NoSQL. Up next, we'll understand how to use NoSQL and how exactly it works. And then we'll look at some different types of NoSQL databases. And after that, we'll have a detailed comparison between SQL and NoSQL database. And finally, we'll conclude the session by understanding some advantages and disadvantages of using NoSQL. And we'll also look when to use SQL as well as NoSQL. So without any further delay, let us dive straight into today's topic on SQL versus NoSQL. Firstly, let us understand what is SQL. SQL, as it stands, is defined as structured query language, is basically a standardized programming language that is used to manage databases, and it performs various operations on data in them. initially created in 1970s, SQL is widely used by many companies and technologies nowadays. SQL is used for modifying database tables and index structures. It is also used in adding, updating, and deleting rows of data. It is also used to retrieve subsets of information from within the database management system. Now, SQL is used to perform various actions such as to insert data, to update data, modify, and delete the data in the database as well. Now, when we talk about SQL, it is important that we talk about relational database systems as well. A relational database system, or RDBMS, is a database system that stores and fetches data in the form of table, that is in the form of rows and columns. Tables are used to store data in relational databases about related objects. Each column contains attributes of data, whereas each row holds a record of unique data known as a key, which helps in making relationship between different data points that is present in different table, which makes us easy to understand. Now, these relational databases, or RDBMS, are managed using SQL language to perform various operations. Therefore, SQL codes are used to retrieve information from these relational databases by doing various interactive operations like using join, create, truncate, delete, alter, and etc. Let us now look at some popular SQL databases. Some popular SQL databases that are available are MySQL, Oracle Database, Microsoft SQL, Server SQLite, and PostgreSQL. Now that we have understood what is SQL, let us now understand what is NoSQL. NoSQL database is a non-relational database management system that does not require a fixed schema. That is, the data is not stored in the form of tables in NoSQL databases. Basically, it avoids any joining or creating or scaling the databases in SQL. The major purpose of using a NoSQL database is for distributed data storage, which is having high volumes of data storage needs. NoSQL is used for big data and real-time web applications. Like, for example, companies like Amazon, Facebook, Google collect terabytes of users' data every single day. So basically, NoSQL database stands for not only SQL or not SQL, and it is introduced in the year 1998 by Carl Stross. Now, traditional RDBMS uses SQL syntax to store and retrieve data for further insights. Now, instead, our NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, as well as unstructured data. Let us now understand why we use NoSQL. We use hierarchical storage structure instead of a table-like structure. That means before relational databases, companies used a hierarchical database system with a tree-like structure for database tables. Now, these early database management systems enabled users to organize large quantities of data. However, they were complex, often required a particular application and in a limited way, which they could uncover the data that is stored. Now, these limitations eventually led to the development of relational database, that is, the data that is stored in tables. So, SQL provided an interface to interact with relational data and allowing the analysts to connect tables by merging on common fields. But as time passed, the demands for faster and more desperate usage of larger datasets became increasingly more important for emerging technologies, for e-commerce and other big giants. For that, NoSQL has became the alternative for everyone. Now, another reason is now we have constant addition of new features and functions in the NoSQL database, right? So that means we know that technology is being rapidly evolved and huge enormous amounts of data has been released on a daily basis, and it's important that we store this data and access in a quick way. Now, NoSQL is the best database to use for large amounts of data or for ever-changing data sets. It is also best used when you have to have a flexible data model or need that don't fit into a relational model. And finally, if you want that there is no relationship between any stored data and you feel it is not important, then you can use NoSQL as well. Let us now look at some popular NoSQL databases. Some popular NoSQL databases are MongoDB, Apache HBase, Cassandra, Redis, Neo4j, and etc. Let us now look at some types of NoSQL databases that are present. Firstly, we have document-oriented. The document database typically stores self-describing JSON, XML, and BSON documents. They are similar to key value stores, but in this case, a value is a single document that stores all the data related to a specific key. Popular fields in the document can be indexed to provide faster retrieval without knowing the key as well. Each document can have same or different data structure. MongoDB, CouchDB, CloudEnd are some examples of document-based NoSQL database. Next, we have key value pair database. The data in this is stored like a key value pairs. Key value pair data stored in database in the form of a hash table. Each key is unique in this case. The value stored may be an integer, a string, a binary object, a JSON object, etc. The key value store based database is simplest database among all the databases in NoSQL database. Redis, Coherence are examples of some key value store databases. Next, we have column based or column store database in NoSQL, which is in this the data stored in grouped columns instead of rows. Every column values are stored separately. It delivers high performance on aggregate functions like count, sum, max, minimum. Group of columns data stored in key spaces like schema in RDBMS. Key spaces contains group of rows or columns, and HBase, Bigtable, Aculomo are some examples of column store databases. And finally, we have graph-oriented or graph store databases. Data in this is represented in the form of a directed graph. It consists of nodes and edges. Nodes represent an entity and any edge represents the relation between the two nodes. Node edge to be unique. Social networks, logistics, spatial data used graphical storage database. Neo4j, Infinite Graph, OrientDB, FlogDB are examples of some graph storage database. Next, let us understand how exactly NoSQL database works. For that, I'm going to take the example of MongoDB database. Now, MongoDB is based on the NoSQL document store model in which data objects are stored as separate documents inside a collection instead of a traditional column and row of a relational database. Now, MongoDB groups data through collections, and basically a collection is simply a grouping of documents that have a same or similar purpose. A collection acts similarly to a table in a traditional SQL database. However, it has a major difference. A collection is not enforced by a strict schema, that is, it does not have any fixed schema at all. Instead, documents in a collection can have slightly different structure from another as needed. This reduces the need to break items in a document into several different tables as it is often done in an SQL implementation. Now coming to document, a document is a representation of a single entity of a data in MongoDB database. A collection consists of one or more related objects. Major difference that exists between MongoDB and SQL in that documents are different from rows. Row data is flat with one column for each value in the row. However, in MongoDB, documents can contain embedded sub-documents providing a much closer inherent data model for your applications. Now, if I just have to map what are exactly and how it is different from RDBMS, a collection in a MongoDB is equivalent to the tables in RDBMS, and a document in MongoDB is equivalent to the rows in RDBMS, and fields in MongoDB is equivalent to the columns in RDBMS. So this is how a document looks in a MongoDB. As you can see, this is similar to a row in RDBMS, but we just have a field and a value that is taken separately instead of a tabular value. And another important thing to note here is that MongoDB supports dynamic schema, which means one document of a collection can have a number of fields while the other document can have less or same number of fields. That is, if a collection can have 4 fields while other document can have only just 2 fields, which is basically not possible in a relational database, which does not exist. It does not support because it needs a particular and a fixed schema in that. Let us now understand some differences between the SQL and NoSQL. Firstly, SQL is a relational database and NoSQL is a non-relational database. That means SQL databases are in the form of tables that can contain rows and columns, and they have fixed logical schema design. All the data in SQL is arranged in tabular format and it is well suited for complex queries. And on the other hand, NoSQL databases is a non-relational database. That means it does not store data in the form of tables and contains collections, and inside every collection there is a document that contains the data of a single entry. This data is stored in the form of a key value pair, unlike SQL where we store data under the fixed schema. So as we discussed, SQL has a fixed schema design and structure, and NoSQL has a dynamic schema design and structure. SQL can handle complex queries, whereas NoSQL can handle large volumes of data.
Now, SQL is vertically scalable. Now, SQL databases support vertical scaling, which means it improves the single server by increasing RAM, SSD, or CPU. In vertical scaling, we are restricted to a single system and we can improve it as much as we want till the practical limit. Whereas in NoSQL database, we can do horizontal scaling because they support distributed computing or distributed systems. In horizontal scaling, we can add another node or computer for better performance, and we can add n number of such servers or nodes as per a requirement. So as discussed, we can add as many as nodes as we want, and this is why we prefer NoSQL for high scalability, because there is no limit for scaling. And finally, it follows ACID properties, that is atomicity, that means transaction should be performed at once or it shouldn't happen at all. Consistency, that means the state of a database should remain consistent before and after the transaction. Isolation, that is one transaction shouldn't affect another transaction and should be independent. And lastly, durability. Now, successful transaction should be reflected even if there is any system failure. Whereas the NoSQL follows CAP property, that is consistency, availability, and partial tolerance. Let us now discuss some advantages and disadvantages of using NoSQL. Firstly, let us discuss about the advantages. NoSQL provides high performance and scalability, and it also has a lot of availability and flexibility. It is open source and it is schema-less as well. That is, you can directly download the NoSQL databases from the internet, unlike some commercial databases that are available in the internet. While on the other hand, there are some disadvantages as well. That is, it lacks the standardization. That means it does not have a fixed query in order to retrieve data from the databases, which result in consistency issues. And since it has all these consistency issues and does not retrieve data properly, it has a limited query capabilities. So that brings us to the end of today's session on SQL versus NoSQL, guys. So you might have a doubt that when you need to use SQL and when we need to use NoSQL. Now, SQL is easiest to work with relational databases. That is, it is useful when you want to perform complex queries using various operations like join and etc. And if you want to perform quick data storage and retrieval operations, you can use SQL. Whereas you can use NoSQL if you are designing a distributed systems and if you want a hierarchical storage structure instead of a tabular-like structure. Also, NoSQL gives you the flexibility to create dynamic structures and can add features as you want. Also, there is no ACID properties during the creation of any applications while creating NoSQL databases as well. So in this way, you can use NoSQL and SQL as per your requirement.
We'll be going through some most asked SQL interview questions by various companies such as Cognizant, Accenture, Deloitte, and other top recruiting MNC companies. Let's get started. The first question is, what is SQL and how does it work? Structured Query Language or SQL is a language to operate databases which helps in database creation, deletion, fetching rows, modifying rows, and so much more. SQL is a standard language for relational database systems. All the relational database systems like MySQL, MS Access, Oracle, Sybase, Informix, and other NoSQL PSQL languages use SQL as their standard database languages. SQL comes with a dozen of advantages, like it allows you to create and drop databases and tables, set permissions on tables, procedures and views, and so much more. SQL is easy to learn as the statements comprise of descriptive English words and sentences and are not case sensitive. We can create and interact with database using SQL in an efficient and an easy way. The benefit with SQL is that we don't have to specify how to get the data from the database. Rather, we simply specify what is to be retrieved and SQL does the rest. Also called a query language, SQL can do much more besides querying. As we discussed earlier, it provides statements for defining the structure of the data, manipulating data, declaring constraints, and retrieving data from the database, depending on various conditions and our requirements. Now, the working of SQL is also very simple. A typical SQL process takes place with the help of a database server and a SQL. Now, if you look at the diagram, we have an end user, we have a database server, SQL engine database, and a record. Now, to understand how SQL works, let us take an example. Suppose John is an HR manager working in an organization. He wants information of all the employees who have joined last year. For that, John writes an SQL query in his laptop to retrieve the data. Now, in order to execute the query, it must interact with relational DBMS, and the request should be a valid query before the SQL engine can process it. The SQL engine then writes to and retrieves data from a database server. Now, to retrieve the data, the query processor is the SQL engine accepts and executes SQL commands from the database server to forward it to an application server. Now, this application server processes the SQL request and sends it to a web server where the user can access the information via SQL database table. Now, if the required data is found in the tables, the database server sends the information back to the user. In this way, John can retrieve the information from the database using SQL. So that was all about SQL and how does it work. Let us now move to the next question. What are the usages of SQL? Or you might be asked in another way, like why we use SQL. SQL is responsible for maintaining the relational data and data stores present in the database. It is used to query and manipulate data stored in the relational databases. Some of the features of SQL are: it is used to execute queries against a database. It retrieves the data from the database. We can perform various operations like insert, update, and delete, and many other operations on SQL database tables as well. And it can also perform complex operations on the database using various clauses, operators, and functions in the SQL. A database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by database management system DBMS. Together, the data and the DBMS along with the applications that are associated with them are referred to as a database system, often shortened to just database. Now, data with the most common types of database in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. The data can then be easily accessed, managed, modified, updated, and organized in these databases. Now, most databases use SQL for writing queries and to retrieve that information from the databases. Now, some popular SQL databases are PostgreSQL, MySQL, Oracle, Microsoft SQL Server, MongoDB, and others. Well, moving ahead, the next question is, what do you understand by tables and fields in a database? A table is a set of data that are organized in a model with columns and rows. Columns can be categorized as vertical and rows are horizontal fields. A table has a specified number of columns called fields, but can have any number of rows, which is called a record. Now, if you take an example of a table that is given here, the salary is a field. In the similar way, employee ID, employee name, job, and department also come under the field. Now, the vertical rows are categorized as columns, and we have 5 different columns, which are employee ID, employee name, job, department, and salary. And the horizontal rows are categorized as rows or tuple, which is basically the information that we put into our database tables. Right. The next question is, mention different types of commands used in SQL. SQL commands are instructions for communicating with the database and are used to carry out specific tasks, work, and functions on database data. Now, SQL commands are further categorized into 4 different types. The first one is data definition language, or DDL. DDL helps the user to define the database structure or schemas that are capable of creating, deleting, and modifying data. Create, drop, alter, truncate are some examples of DDL commands or statements. We have data manipulation language, or DML. DML is used to modify or manipulate data present in the database tables. Insert, update, select, and delete are some SQL commands that come under DML. Next, we have data control language, or DCL. DCL is used to control access to the data stored in the database by granting and revoking permission to the user. And finally, we have transaction control language, TCL. It is used for managing and controlling the transactions in a database to maintain consistency. commit, and rollback commands come under TCL. We also have data query language additionally, which is used to retrieve the data from the database. Select commands lets the user query the database to fetch data from the tables. The next question is, what are the statements used under DML commands? Now, this might be a follow-up question for the previous question that we have discussed, which is types of SQL commands. Interviewer wants to know whether really understood the statements that you have covered under the DML commands and understood them in a very good way. Now, for that, you have to be familiar with all the DML commands. So you might be asked any one of these commands in your interview as well. So there are 4 different types of statements used under DML commands. The first one is select. This command is used to fetch data from a database table. Next, we have insert. This command allows inserting data into the table or database. That is, if you want to enter a new record into our already existing table, you can use the insert command. Next, we have the update. This command allows modifying a data in the table. Now, for some reasons, if you want to change the data that is present in your table, you can use the update command. And finally, we have the delete. This command allows deleting specific rows or all the rows from a table. Moving ahead, the next question is, what is the difference between delete and truncate? Difference between delete and truncate command is the most common part of an interview question and is asked in various interviews by the recruiters. They are mainly used to delete the data from the database, but eventually they have some differences between them as well. Now, the first difference is the delete command is used to delete a specified amount of rows. That is, you can delete either a single row or more than one row. Whereas the truncate command is used to delete all the rows at a time from a table. Delete is a DML command, which is a data manipulation language, whereas the truncate comes under the DDL, which is the data definition language. Now, using delete, there may be a where clause in the delete command in order to further the records, whereas in truncate there is no where clause in the truncate command. Now, in delete command, the changes can be rolled back. That is, if you have deleted a particular of rows, you can use the rollback statement to bring back those records that you have deleted. Where in case of truncate, once the changes are made, they cannot be rolled back. Now, delete is slower than truncate, whereas the truncate is faster than delete. Now, that's because this delete command is very slow because it maintains the transaction loss, whereas the truncate command is fast because it deletes entire data at a time without maintaining any transaction loss. As in the same way, the delete statement occupies more transaction space than the truncate because it maintains a log for each deleted row, whereas the truncate statement occupies less transaction space because it maintains a transaction log for the entire data page instead of each row. So those are the main differences between delete and truncate. Right, moving ahead, the next question is, what are the constraints in SQL? Constraints are a set of rules imposed on the tables of relational databases. Constraints help in maintaining the data accuracy, integrity, and reliability of a database. Constraints can be imposed at the time of creation of the table or after its creation as well. Now, constraints can be a column level or table level. Column level constraints apply to a column and the table level constraints apply to the whole table. Now, the following constraints are which are commonly used in SQL are: the first one is unique constraint is specified with a column tells that the all values in a column must be unique. That is, the values in any row of a column must not be repeated. Next, we have primary key. A primary key is a field which can uniquely identify each row in a table, and this constraint is used to specify a field in a table as a primary key. Next, we have foreign key. A foreign key is a field which can be uniquely identified each row in other table, and this constraint is used to specify a field as a foreign key. Next, we have the default constraint. This constraint specifies a default value for the column when no value is specified by the user. Next, we have the check constraint. The check constraint helps to validate the values of a column to meet a particular condition. That is, it helps to ensure that the value stored in a column meets a specified condition. And finally, we have the not null constraint. This constraint basically tells that we cannot store a null value in a column. That is, if a column is specified as not null, then we'll not be able to store null value in this particular column anymore. And you have to give a value to it.
So that was all about constraints in SQL. Right. The next question is, what do you understand by the term clause, and explain various clauses in SQL? Now, clauses are built-in functions available to the user in SQL. With the help of clauses, we can deal with data easily stored in the table. SQL clause helps to limit the result set by providing a condition to the query and helps to filter records from the entire set of records. Now, we have various clauses in SQL. Some of them are, the first one is where clause. Where clause is used to filter the records in the database. Order by clause. Order by clause is used to sort the data either in ascending or descending order using the ASC and the DESC keywords in the SQL queries. And next we have the group by clause. Group by clause is used to group entries with identical data and may be used with aggregation methods to obtain summarized database result. This can be used when you are performing aggregate operations for the database tables. Next we have having. Having is similar to that of where clause, but it filters the records or the rows where aggregate values meet the specified conditions only. Next, we have the limit clause. Limit clause is used to specify only a certain number of results in the query of a resultant set table. That is, if you want to specify or retrieve only a particular number of records, let's say the top 50 or the first 50 records in the table, in that case, you can use the limit, which will specify only a limited number of records. And finally, we have the distinct clause, which will basically delete all the rows having duplicate values. That means if in your database table, if any record has been repeated multiple times, then the distinct clause is used to discard all those rows. Moving ahead, the next question is, what are different types of operators used in SQL? Operators are the foundation of any programming language, be it SQL or any other programming language like C, C++, Java and other programming languages. Now we can define operators as symbols that help us to perform specific mathematical and logical computations on our SQL databases tables. Now in SQL we have multiple types of operators available, which we'll be discussing shortly. Now we use SQL operators to specify conditions and statements satisfying a query of a desired data input. Now the first type of operator is basically the arithmetic operators, which are used to perform day-to-day operations like addition, subtraction, multiplication, division and remainder and modulus operations. Next we have the bitwise operators, and in bitwise operators we have bitwise and, bitwise or, bitwise XOR, etc. Next, we have comparison operators. As the word suggests, we use this operator to compare the values in our SQL database table. Equal to, not equal to, greater than, not greater than, less than, not less than, not equal to, etc. are some examples of comparison operators. Next, we have compound operators, which are similar to that of arithmetic operators, but examples such as add equals, multiply equals, subtract equals, divide equals, and modulo equals. Next, we have the logical operators. In SQL, the logical operators are used for filtering the data and getting precise results based on a given condition. The SQL logical operators are also used to combine multiple conditions. These operators can be combined to test for multiple conditions in a select, insert, update, or delete statements. Examples of logical operators are all, and, between, not, exist, or, in, like, and is null. And finally, we have string operators, and some examples of string operators are string concatenations, wildcard, character matches, and etc. The next question is, name the operator which is used for pattern matching in SQL. The SQL-like operator is a command that is used for pattern matching that determines whether a specific character string matches a pattern. Like operator is frequently used in a where clause to look for a specific pattern in a column. Now the SQL pattern matching provides for pattern search in data if you have no clue as to what the word should be that is present in your database table. Now this kind of SQL query uses wildcards to match a string pattern rather than writing the exact word. The like operator is used in conjunction with SQL wildcards to fetch the required information. Using the percentage wildcard symbol to perform a simple search, which basically matches 0 or more one character of any type and can be used to define wildcards both before and after the pattern search in our database table. And similarly, we have the underscore wildcard, which matches exactly one character rather than multiple characters of any type. It can be used in conjunction with the underscore as well as the percentage wildcard as well. So in this way, the SQL like operator is the one which is used for pattern matching in SQL. Moving ahead, the next question is, what is the difference between SQL and MySQL? This is one of the most frequently asked questions in your interviews, and the interviewer expects whether you're familiar on the differences between the SQL and MySQL. So SQL is basically a programming language which has a particular syntax in English words and etc. Whereas MySQL, it is an RDBMS, which is a relational database management system. SQL is used for querying relational database system, whereas MySQL is used to modify and delete data in the database in an organized way. SQL, though considered as a language, we have SQL Server, which is a licensed product of Microsoft. MySQL is an open source platform managed by Oracle Corporation. SQL provides adequate protection to SQL servers against intruders. Whereas MySQL, being an open source platform, security cannot be reliable and can be at risk sometimes. And finally, SQL doesn't support any connectors, whereas MySQL support connectors such as Workbench tools and many other such tools to build database, etc. Next, what is the difference? What is the main difference between where and having clause? Now, where clause is used to filter the records from the table based on the specified condition, whereas having clause is used to filter records from the group based on the specified condition. Where clause can be used without the group by clause, whereas the having clause cannot be used without using the group by clause. Where clause implements in a row operation, whereas the having clause implements in column operations. Where clause cannot contain aggregate functions, whereas having clause can contain aggregate functions. And finally, where clause can be used with select, update, delete statements, and on the other hand, having clause can only be used with the select statement. So these were the some main differences between where and having clause in SQL. Now the next question is, what are keys in SQL and why do we use them? The SQL keys is an attribute or set of attributes which helps you to identify a row in a table. They also help in establishing a relation between multiple tables in the databases as well. Now the reason why we use SQL keys are, keys identify each record separately and uniquely. Now if you're working on a large data sets, you might want to specify a different key to each column because you want to uniquely identify each and every record using certain columns, right? So in that case, you have to use keys. Now, keys also allows the user to establish and identify a relationship between tables. And finally, it accesses or manages the stored data quickly and right. Moving ahead, the next question is, mention different types of keys used in SQL. Now, this is again another follow-up question to the SQL keys which we have discussed earlier. And the interviewer or the recruiter might want to know whether you have the knowledge of various different types of keys that are used in SQL. Now, there are primarily 4 different types of keys used in SQL. The first one is basically the primary key. The primary key in SQL is a group of fields or columns that can uniquely identify a row in a table. Now, let's say if you're working on an employee table, so in that case, you can see employee ID as a primary key because it uniquely identifies each and every record or the details of an employee in that table. Next, we have the super key. A super key is basically a combination of all possible attributes which can uniquely identify the rows in a table. Next, we have the candidate key. Candidate key can be identified or defined as a set of one or more columns that can identify a record, a tuple uniquely in a table. So along with the primary key, there may be some other columns of fields where you can easily identify a unique manner. So in that case, you will use the candidate key. Now, for example, let's say Aadhaar card, PAN card are some examples of candidate key as
They also work in a similar fashion to that of primary key, which uniquely identifies the records of those employees in the table. And finally, we have foreign key. A foreign key is a set of attributes in a table that refers to the primary key of another table. So these were the different types of keys that are used in SQL. Right. The next question is, what's the difference between char and varchar data type? Now, speaking of char, it is a fixed length character string data type, whereas varchar or variable character is a variable length character string data type. Char data type can be a set of multiple bytes, whereas the varchar can accept character strings up to 255 bytes. Char data type can be used when the character length is known, whereas varchar data type is used when the character length is not known. Next, the char is used when the character length of the data is same, whereas the varchar is used when the character length of the data is variable. Now, char is considered as a static data type and is given static memory allocation because it only stores the character values, whereas the varchar is considered as a dynamic data type and is given dynamic memory allocation because it has various string like characters and variables to be stored in the tables. So that were the main differences between the char and varchar data types. Moving ahead, the next question is, what are aggregate functions in SQL? An aggregate function in SQL performs calculation on multiple values and returns a single value. It allows the user to perform complex calculation on a set of values to return a single scalar value. We often use these aggregate functions with the group by and having clauses of the select statement. Now, SQL aggregate functions are further classified into 5 types. The first one is count. Next one is sum. Next, we have average, and then we have minimum, and finally we have maximum. Right. Next question is, write an SQL query to find second highest salary from employee table. Now, other than some definitions and other theoretical questions, you might be asked to write some basic SQL queries during your interviews. Now, we all know to find the highest salary in employee, the following query is select ID employee name max salary from employee. Basically, we are selecting ID employee name as the columns in our resultant set, and we are using the aggregate function max to the salary field, which will basically retrieve the maximum salary of that employee present in that employee table. Right, now this is clear and it's a piece of cake to do, right? Now, to find the second highest salary in employee, the following query would be select ID employee name maximum salary from employee where salary is less than. Now we have to use a subquery here, which is select maximum salary from employee. Now, what this query basically does is it basically processes the inner query, which is select max salary from employee. Now, once it executes this, now the outer query gets executed, which is it will display the ID employee name maximum salary of the employee whose salary is less than the maximum salary which you have calculated earlier. So in this way, you can find the second highest salary in employee using a subquery. Now, the next question is, what are subqueries in SQL and why we use them, which is obviously a follow-up query that we have discussed earlier. A subquery is basically a type of query which is written inside another query. A subquery becomes a part of a larger query, and a subquery is also called as inner query or a nested query. A subquery provides data to the main query, also called parent query or the outer query. A subquery is basically a select statement that is embedded in a clause of another SQL statement, and the inner query is executed once before its parent or outer query so that the results of an inner query can be passed to the outer query. Now, what I mean is, like, let's take an example here, which we have is select name listed price from orders where listed price is greater than select average listed price from orders. Now we have a subquery which is select average listed price from orders, which is basically an inner query or the nested query. Now first, this part of the query gets executed where it will select the average price of the listed prices in the orders table, and finally it will display the records of all those items and its listed price on the orders, which is greater than the average of the listed prices, which is basically the inner query. So in this way, we can use these subqueries to perform
complex operations on our table databases. Right, moving ahead, what are joins in SQL and mention it types? The SQL join clause is used to combine records or rows from two or more tables in a SQL database based on a related column between one or two tables. SQL joins are mostly used when a user is trying to fetch data from multiple tables. Join keyword merges two or more tables and creates a temporary resultant set of the merged tables. We can join the table using a select statement and a join condition, and the query is followed as select table1 dot column 1 comma table1 dot column 2 comma table2 dot column 1 comma table2 dot column 2 and so on from table 1 join condition, which is basically the type of join you want to apply to your SQL query. It may be inner join, outer join, left join, or outer join. On table 2 on provide the condition on which you want to join the tables, that is table1 dot column is equals to table2 dot column. So in this way you can use the joins in SQL as well. Now moving ahead, the next question is what are joins in SQL and mention its types. Now we have basically 4 different types of joins in SQL, which is the first one is inner join. The inner join basically returns records that have matching values in both the tables. That is, if you consider tables and if you want to get the common values that are present in both the tables, in that case you will use the inner join. Next we have the outer join or full outer join, which basically returns all the records when there is a match in either left or right table. Now outer join basically what it does is no matter if it has any matching values or not, it will display all the records from both the tables, that is table 1 and table 2. Next we have the left join. Left outer join returns all the records from the left table and only the matching records from the right table. Now left join is used only when if you want to display the records from the first table and only the matching values that are present in the second table. So in that case you can use the left outer join. And finally we have the right outer join or right outer join, which basically returns all the records from right table and only the matching records from the left table. So in this way you can use different types of joins in your SQL queries as well. Right, the next question is write an SQL query to find names of all the employees that begins with A. I think this is a simple query, and to display the details of all the employees whose name begins with A, we need to type this following query, which is used with the like operator, and the query is followed as select star from employee where E name, which is basically I'm taking as the common name, like a percentage. So this will basically display records of all those employees whose name starts with A. And similarly, you might be asked to display the names of all the employees that ends with A, and the following queries are similar to that of the first one we have discussed, and the only difference is you have to change the percentage sign, and the query is followed as select star from employee where E name like. Now instead of putting the character A in the first, we have to place the percentage wildcard first and then the A character, which basically display all the records of employees whose name might be starting with any character, but it should end with A. Moving ahead, the next question is write an SQL query to return even and odd number records from a table. Now to find and return the records with the odd or even values, we need to check the remainder when we divide the column value by 2. Now when the remainder is 0, that's an even number, otherwise that's an odd number. Now if you take an example here, in order to display even number of records, we are using the modulus operator here. And the query is followed as select star from table where ID modulus 2 is equals to 0. Now if you take an employee table, let's say they're having employee ID starting from 100. Now 100 modulus 2 is basically equals to 0. So it basically returns the even number records there. And similarly, all the employees having their ID even numbers, that is 100, 102, 104, 106 and so on, and all those records will be displayed in a resultant set. And similarly, in order to display odd number records, we use the following query select star from table where ID modulus 2 not equals to 0. Now if you take the employee ID as 101, when you perform the operation 101 modulus 2, you have the reminder as 1, which is basically not equals 0, and it is a odd number record. So employee is having employee IDs like 101, 103, 105, and so on in odd numbered places will basically return the records. So in this way, you can return even and odd number records from the table using the modulus operator. Moving ahead, the next question is, explain what is an alias in SQL and why we use it. Alias in SQL is basically a temporary name that is given to a table or column while writing a query. This is usually done when the column or table names are long. Giving aliases makes the table or column name more readable and is also preferred when there are a lot of queries written for a table. The alias is based in SQL is a temporary change and only exists till the duration of that. Now, to give an alias name for a column, the query is followed as select column name as alias name from table name. For example, I have the column name as employee name and I just want to give the alias as EN. So in this way, I'm using the alias name for the column name as well. And similarly, if I want to give alias name for table, the following select column 1, column 2 from table name as alias name. So just like in a way you've given the alias name for your columns, you can similarly the alias name for your table as well. Moving ahead, how to create a new table from an existing table. Now, a copy of table can be created from an existing table using the combination of create and select statements. Using these two statements, we can either select all the columns or only a specific column from an existing table. As a result, the new table will be replaced with all the values of the existing table, and the where clause can also be used as an optional statement to select the specific columns from the table. And the syntax is followed as create table, new table name 1, as select, mention all the columns that you want to retrieve from the existing table, which is from existing table 1, and you can also specify the condition using the where clause as well. And finally, the question is, what are the applications of SQL in real life? Now, SQL is used in various fields in nowadays. For example, SQL is used in banking, it is used in education, it is used in finance sector, it is used in healthcare, it is used in e-commerce sector, it is used in traveling sector, it is used in manufacturing sector as well. Now, talking about banking, SQL is one of the major components of the banking sectors. Like banks store the account details of customers and the transactions that are done on a daily basis in databases. Now in education, schools and universities use SQL and databases to store and retrieve information about their students, faculty, and staff. SQL is also used in finance sector, where it's another massive area where SQL queries are used regularly in managing the assets, revenue details, shares of the companies as well. Execution and retrieval of data plays an important role for all the businesses and finance segments to make strategies and derive insights from it. SQL is also used rapidly and extensively in healthcare sector as well, where hospitals and other medical centers use SQL to store the details of their patients without any hassle. It also helps in maintaining all the documents and the bills of the patients. And similarly, in manufacturing sector also, we have a lot of applications of SQL as well to track the shipments, etc. Now in travel aspects of also we use the SQL, wherein the details of the customers who are traveling can also be used with the help of SQL. And finally, SQL is also used in e-commerce. Like we have Amazon, which is probably one of the biggest e-commerce companies in the world, which is used to locate or heavily rely on SQL to make better decisions and provide solutions and service to its customers. So these were some of the applications of SQL in real life.
And that brings us to the end of today's tutorial, guys. I hope you all understood all the topics and concepts covered in today's session. Thank you for watching the video, guys. If you found this tutorial informative and helpful, make sure to leave us a like and share it with your friends and colleagues. We are glad to have such a great response on this training series. So if you guys haven't checked out the part 1 and part 2 of this SQL training series program, make sure to check out that on our channel.
We'll leave the description in the comment section below, so make sure you don't forget to check that out. So if you love watching tech videos and if you want us to cover some more technologies and multiple programming languages in our next training series program, let us know which technology or programming languages we should cover in our next session. And if you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and our team of experts will be more than happy to help resolve all your queries at the earliest. Until next time, stay safe and keep coding.